2 seconds. Give me some net connection. Oh, let's copy. Not this one. No, not this one. Try to download the Google Drive. Huh?
Doing it. While you're doing it, shall we have some fun and games here?
Yeah.
Huh? So this is just back to the audience while they are working with the magic box to see what can be done. Uh, a quick thing to keep everybody energized. So this is there are 24 coins. Okay, out of 24 coins, one coin is heavier than the remaining 23. 23 coins are the same weight. One coin is heavier than the remaining 23. Uh, how can you isolate that one coin in three weighings? You have a pan which can do simultaneous two weighs. Okay, comparative balance. You have to weigh and isolate in three times that heavier coin. That ladies raised the hands. Okay, go ahead. Go ahead. How will you do it? Why don't you आ जाओ.
Come forward.
Okay.
Yeah. Yes.
So,
Go ahead.
okay. So, we had 23 coins, sir, right?
24.
24. Okay. So, first we take the half of like 12 and 12 and put both the side. And wherever the side is higher, like weight is higher, then took those 20, like 12 coins. And after that, again, half and half. And we have 6 and 6 coins. Then whichever side is higher, we took those 6 coins also. And again, we took those 3 and 3. And the side. Oh, right, right. Okay, I was thinking.
Anyone else? Huh? I think so. You're too senior. The engineers are here. Let's hear them. Huh? Okay. I'll take it here.
Whatever she said, after doing those 2 steps, I'll take 6, and the heavier one, I think I'll be able to just stay.
Sir, what about you? Come.
So we will divide it into 3 parts, 8, 8, 8, and we will weigh 2 8s. If they are equal, then it is definitely from the third one. Otherwise, we will get among the two. So we have got the bunch of 8, which include the heavier coin. Now we will divide it into 2, 2, 2. Sorry, we will divide it into 2 to 2, right? And then when we weight that, we will find if both have the same weight, then the coin will be among the those two. Otherwise, the bunch of 4. So let assume the first case that coin is from the these two. Then we can divide the heavier one into weight again, and we will find the coin. Otherwise, we have the bunch of 4. We will again divide into 2, and the step will be repeated. Otherwise,
You can share between the group.
okay, sir.
Okay. So the answer is first after 24, 8, 8, 8. You got that part right. Okay. So either they are the same or you isolate which is heavy. The moment you have isolated the 8 which is heavy, then you do 3, 3, 2, weigh the 3 and 3. अगर सेम है तो इन दो के अंदर हैवी है, इसलिए थर्ड वेइंग के अंदर आपको पता चल जाएगा. नहीं है तो उसके अंदर 3, 3 के अंदर जो भी हैवी था उसको लेके कंपेयर एनी टू इन द थर्ड वेइंग. Yes. So what's your name and your friends? Okay. Okay, but you're not naming them. वो chocolate share करनी पड़ेगी.
Recently has joined Applied Material in Bangalore, maybe a few months ago. So I knew as you were asking what you have described what Applied Materials are doing, I have heard that they have a strong control component, control system. So which I might not have get from you. If you can tell, then our control, here we have a control system group in electrical engineering or in other department. So they can be benefited for further collaboration. I retired from IIT Bombay and joined as a visiting professor here.
Sir, a pleasure to get to know you. We have every business unit represented in Applied Materials India. So there will be a control systems group. Off the cuff, I can't tell you more about it. but we can take a discussion on it offline.
Upright.
I can even link you to people in our business groups who can evolve that discussion further.
Yes, yes. Actually, my former PhD students just joined few months, Asif, you
Okay.
know, in applied material.
Sir, it's
And one
wonderful.
of my colleagues at IIT Bombay has a collaboration, Vivek Natarajan,
Okay.
who is a professor there.
Yes, sir.
Yeah,
we,
this
we,
is
we work very closely with IIT Bombay.
IIT Bombay, yeah.
Yes.
I served 35 years, retired, and came here as visiting.
So we have a base there and really love applied
Yeah.
materials, IIT Bombay.
Right. Thank you. Thank you.
So if anybody has a question further for Dr. Ashwani, we thought the questions we'll take in the panel session, but since we have got some time, any other question? For, yeah.
So, Ashwani, you mentioned about this panel level packaging tools. So, can you name a few tools that the Applied Materials is developing for panel level packaging?
Okay, it's a tool portfolio. The portfolio is named Tango, and Tango will see the conception of a panel level packaging is this. In the transition from the conventional packaging to wafer level packaging, the geometries had shrunk dramatically and it was not seen as a sustainable model where you try and create the ball grid arrays on that reduced package. So in the new era, the packaging is done in bulk. Once you have created the dice, you reconstitute it on a wafer, on a substrate.
So, just to add, I myself have worked on developing panel level packaging with Intel Corporation and Arizona.
Okay.
And I worked on the line.
Okay.
Yes.
So
I'm aware of the technology and the wafer.
So I'm just doing it for the rest of the group also. Because the geometries have shrunk, they are now reconstituting the dies on a substrate. And originally the constitution was done on a 300 wafer substrate only. Okay, then they were actually using the conventional front-end packaging tools to coat it with a back layer and then create the RDL redistribution layers in that particular on that particular substrate, and then flip it and then complete the the panel level packaging. Then dice it. After doing everything, then you dice it. Then it's the finished thing being diced. Now imagine if instead of processing on a 300 wafer, which is circular, you start doing the reconstitution on a larger carrier. So people started looking at a carrier of 300 cross 300 and they used different substrates, not necessarily the silicon wafer. They started using, originally it was Samsung, which actually evolved a conception on this. So they used glass from their glass factories, display factories, and they used a glass substrate for it. The current genre is driving towards copper substrates as well. And on a copper substrate, they talked of 300 by 300, then they went to 600 by 300. Now they are at 600 by cross 600. So just in the area of processing versus a wafer of 300 diameter, you have reached a stage we are actually processing 8 times the dies in the versus the wafer level packaging. So your OPEX cost is dropping that rapidly on this. That is the conception. And the work is being done actually out of our Coimbatore team. They created the Tango products. And the Tango products has a range of portfolios, with different level of productivity, which is there. And while the design is done here, the production is done elsewhere. Someday, maybe it will happen here.
If I may ask a follow-up question on the same, would Applied be interested in collaborating with academic institution to develop such tools in India? As you just mentioned that right now design is done in India.
Okay, Applied is very sensitive about its technology and the IP relationships. I cannot answer to that off the cuff. We should take the discussion offline. Okay, but we do a lot of research with academia in India. That is a fact. So we have, as I covered in my other presentation, we invested a lot in the infrastructure at IIT Bombay. We have given them 2 labs, but other than that, we have 85 crores we have spent as grants from applied to academia in India. So we should discuss that separately.
Thank you. Thank you for the questions. So we'll continue with the next talk, Dr. Arpan Pal.
Thank you, and sorry for this, I would call the problem that cropped up. I don't know, it was opening and then suddenly the file was not open, and I had to go to my Google Drive to download it again. And when I was trying to do that, it was trying to authenticate to my phone, and my phone was not having the data connection. So lot of blue, but hopefully everything is sorted now. So let me start, and thanks for inviting me here, and I'm really excited to present what we do in this area. And before I start on this topic, which is the device edge computing towards embedded intelligence systems, let me give a couple of minutes on introducing the TCS research. So if you see TCS research, I think TCS starts its research in TRDDC Pune in 1981, long back actually. We just kind of completed 30 years of that anniversary. And currently TCS research, we are around more than 1,000 scientists working in vast different areas, covering obviously the computing and software sciences is the fundamental. But as we realize that there's a lot of multidisciplinary party here, so we also have research in physical, chemical, and biological sciences and behavioral sciences. We have scientists in those areas which actually interact with I would call the computer, electronics, and software people like us, and we kind of try to build things together. So that is one interesting aspect. And we also have what we call now, for past 2 years, we have business unit labs. The sharing is going off. So I have to share again. It's fine? Okay. So here the share has come again. So effectively that we also have some business labs now, which are now kind of bringing us problems directly from the customers, and we try to solve that. And from the academia interaction side, TCS has what we call as a co-innovation network with academics, and we kind of collaborate with many academic institutes across the world, including top IITs and other within India also. And 2 very interesting scheme that is there today is we actually sponsor 40 PhDs every year, which is with a very high scholarship, which is called TCS Research Scholar Program. And also, it's something I think many of you might be seen it. And the second thing that is there is also we are trying to work out whether we can actually attract a lot of internships into our labs if IIT permits, and as a credit course, there's a capstone project with the industry. So we are trying to encourage all those things, and we have research advisory and many other way we are actually engaging with our academic partner, and I hope some similar kind of things will happen. We start with IIT Jodhpur also, and Professor Agarwal is already our research advisor, and we want to get into the nanosystems, and we are trying to do that. So with that as a background, so let me now start on my topic of this device edge computing and why we think it is a very important thing. So if you see the history of embedded devices, like the era of 2000 to 2010 was the era of internet connected devices. But I would call it was more like a rendering device. That's what the research happened. And what you see today as OTT, the OTT smart TVs, kind of the research actually happened in 2010. It kind of stabilized there, but the market didn't grow that much. It needed a COVID and a pandemic to really push that market up. And now you see the OTT has proliferated. And from 2010 to 2020, the next decade was the IoT decade. And we are slowly seeing that IoT also kind of it is becoming a mature technology. And we'll see that it took around 7 to 8 years to commercialize that thing. IoT also proliferating very fast, but maybe another 3-4 years you'll see IoT everywhere. And that was there in the previous talks also, we saw it. And the era that we are getting in from the research perspective is what we call as AIoT. or intelligent IoT, AI plus IoT, whatever you want to call it, intelligence at edge is the next era of research, which may take another after research may take another 3-4 years to actually go in a commercial stage. So there is a kind of a wave that goes in. But the interesting part of the AI IoT is this drivers. If you see any embedded device has this constraint on CPU, clock, memory, battery life, and bandwidth. It is always a constant, doesn't matter. Maybe 20 years back, we are talking about KBs of memory. Today, we may talk on MBs, now we even talk about GBs. But whatever it is, when you talk about GBs, the cloud is at TBs. When you used to use that KBs, then cloud was at MBs. So there will be always an order below, and we have to handle it, whatever way it goes. So, and always there is a cost in the middle. Because we are talking about devices that people can carry, and everybody's thing, the cost is always an issue there. So how do we actually optimize across these 5 dimensions together? When we actually, and still build intelligence at edge is something that we have to look at. So why do we first thing is, let's see why do we need it. So effectively, if you see, if you think about the sensing, is the perception and the analytics is the cognition corresponding to the human system. So effectively, if you see, this is a typical IoT stack where the devices and sensors, then you have the device edge, which is kind of devices compute, which are very close to the sensors, or sometimes they house the sensors themselves. And then comes the network tier, where network edge and I would call network switches and other devices come in, and then you go to the cloud data center. So that is the flow you usually see. Scope of my talk will going to be on the part that I have marked. That is the part where more and more it is something like what is happening. It is a kind of very interesting to see how the history is repeating. Like we had mainframes in 70s. I would kind of put it equivalent to the cloud or a large data. Then we went back to PC. Okay. Then we kind of went back again back to the internet and went to the cloud. Now we are coming back with a cloud mobile. And again, I'm telling we'll again come back to only edge or only devices also. So basically, this is a kind of a back and forth is happening. And each has its own business cycle through which it will go through. And why it is important, if you think about it, I kind of, if you see this as a mental map, this kind of system, we have a physical, I would call world, and we have a physical object. And there's a kind of a feature of interest of the physical object we want to measure. Give a simple example. I have this room, which is my physical object. I can put a temperature sensor here, which is actually measuring a feature of interest, which is the temperature of this room. And to measure it, I put sensors and I observe that data. So effectively, if I want to observe the heat condition of this room, I'll put a temperature sensor. Why we need analytics now? Now, suppose the sensor data, I get temperature and I measure it. That's what, if you get your weather data, you get your temperature, you are done. But in real practical problems, what we want to do is, it is the inverse problem. Suppose there was a fire in this room. We know that the fire will increase the heat content and we know the temperature will go up. But suppose from knowing that I'm measuring the temperature, I have to infer that there is a fire. So I have to find out the cause. Sensor is the effect. It is the inverse problem. Maybe now you can imagine for this example, it may be trivial. But most of the sensing problem, this inverse problem is not trivial. And many times, so basically you're actually finding, so that's what I'm telling you. Basically, if the sensor is a function of the event, the cognition is basically an inverse function of that measurement. And sometimes that inverse we may not know. Especially like if it's human body, we don't even know the forward function. Forget about the inverse function. We don't even know how our brain works. Some cases you know the forward function, like maybe I would square the machines and all. Still, it is very difficult to construct the inverse function. And that is where AI is playing a big role. So what I'm trying to tell, AI is not something a fancy thing. So in order to solve these problems, you may have to bring in AI to solve this. So that is one big challenge. And assuming that you can solve it, the next problem, so let me now talk about different applications that are coming in this space. I'll talk about it in detail, or 1 or 2 slides for each of these. So definitely we see these 4 or 3 areas of thing. People sensing, where actually we sense human body, or people, and different ways you can do, and many clinical and non-clinical application can talk about it. Then we talk about different inanimate objects on this earth, the machine, material, and infrastructures that people build. Because these are two are different, because not only the physics and the chemistry of the sensing is different, the application is also different. What you want to do with it. Maybe when I do machine sensing, I may want to predict the health of the machine so that I can maintain it better. When I am doing people sensing, I'm predicting the health of people so that I can maintain my body better. So there is an analogy, but the way you do is completely different. And third thing is basically the earth itself. So not only about the machine, material, infrastructure, and the people which is looking at the earth itself has to be sensed now, which is called as earth observation or remote sensing. Satellites and drones coming in there to do that kind of thing. So these three are the broad areas in which we are seeing applications. And effectively, if you see the lower chart, where what we see is that it is the intersection of what we call as people, machines, and the organization. And whenever you see this intersection of people and things is your robotics, intersection of business organization and the things is your IoT, and intersection of business and people is your AR, VR, XR. So these are the three I would call dimensions in which we are seeing all whatever application put, mostly it will fall in this bucket. But when you want to do it, these are the typical edge devices that are, you can see these robots and the wearables and the smart glasses and many IoT sensors. These are the typical edge devices, which not only has a sensor, also has some compute capacity. But why you want to do it in the edge? That you may ask. The reason we want to do it in the edge, the intelligence is like, what are the cases the data shouldn't go out to the internet? One part is very obvious, that if I want my data to be private, I don't want to send it out. Suppose there's an app in your phone which is monitoring your activity. You'd be preferring that analytics of the activity should happen on your phone itself. I don't want to send it out because the privacy issues are there. So that is the inherent privacy issue. But even if I don't have a privacy issue, if I have a low latency application, like I'll tell you one application we are doing with someone, semiconductor manufacturing company, they are inspecting this wafer with a camera. And they are in real time, at the wafer is getting in the assembly line, they are trying to find out if there's a defect in the wafer using the camera. They want that within 3 milliseconds, if I cannot detect that defect, it is not useful, because it is a closed loop control system. So we cannot wait for that. And we have found if we actually use it on the internet, if I send the data back on the cloud and can compute it, no internet, even 5G today, no way it can give that latency. So you have to do the compute analysis in the edge. Then obviously there is a low power applications. And I don't know whether you realize it, the compute versus communication, the energy. I don't know when you realize it, that if you play a video on the net, how much battery goes vis-a-vis when actually you downloaded the video and you play it within your. So effectively, it is thumb rule is around 10:1. So you can expend 10 times more energy if you're sending data back to the cloud. But suppose I could play it locally or reduce the data locally, actually I save that battery, even though I expend more energy for compute part of it. So that is another driver. And the reliable part. Whatever I do, if I have a mission critical application, suppose I had a glucose monitoring system in my, you have this smart insulin pumps, which is kind of controlling my and putting that, calculating that how much insulin I is injecting for the diabetes people. I will not rely on a unreliable internet connection to, like I can come into the auditorium, my device may stop working. So there's an issue. So there are applications where this is becoming very important. And I'm not trying to, I think everybody understands this, but effectively this knowledge pyramid, if you go up from the descriptive to diagnostic to predictive to prescriptive analytics, we have to start looking at machine learning and artificial intelligence as a major tool to do it. But what is the challenge? One part of the challenge is, if you see, what I was saying, that the paradigm of computing has changed. Traditionally, we are taught that I will have a computer, I'll have a program, I'll input data, and it will output something. Today, if you see, I don't do that. I have a computer, I have data, I have a label on that data, which is the output. And what it churns out is the program, which is your model. So today, you don't really need programmers anymore, effectively, if you see. You need people who can actually take those models and stitch it together to create larger systems. So, but as this, so basically, so the data is becoming very important. Data which has the output labeled. Labeled data is a most important part of today's year, not the program. That's first thing. But the problem, the second part is about this, that more and more we go into deeper into AI. Traditional machine learning, if we use, I think many people use it here, we have to go through this feature, signal processing, feature extraction, and many other things, which is not scalable. Every time I get a new problem, I'll spend 3 months, 4 months to know what features of my signal will be useful, what feature of my image will be useful. So it is always for business, it is a cost. People are not ready to pay for it. That is why deep learning is so popular. Deep learning does the feature engineering for you. That's good. But now the problem is deep learning produces very massively overly parameterized, very large models, which kind of violates our first principle I put in the beginning. Constant device, small device. So how do I use DL, but still use small devices on that? How do I put deep learning output? So that is, I think, it's a big challenge today of future that is going to be there. Everybody is going to face it. But most of the cases, people are already running big models in the cloud. Now I given those edge requirements, latency, privacy, those things you have to bring back to edge. Do I build those models again? If you try to build those models, maybe the data is not there. So how do we create that? So this is a big challenge that is there now. Just to go through some applications, like I'll give you, so this is one thing that we did over our sister Tata Steel, is they have this coal conveyor belt. Now you see, these are the example of that real-time control I was telling about. You have the coal conveyor belt. You have seen that in any steel plant. You have seen that big slide thing that going up. So they feed the coal from below with that slide, and it feeds on top of, goes inside the furnace on top. Now all these coal are stored in the ground, and it gets kind of contaminated with other materials. Wood, concrete, everything will come. If a concrete goes in there and the coal goes to the crusher and it goes to the furnace, if the crusher blade breaks, it is they told every day 1 crore. That's the loss to stop that plant. The challenge here is now not only you have to do it in real time, even the wood and the coal, that concrete that gets mixed with the coal, they're all covered with coal dust. All are black. How do we do it? Like I think he was telling about hyperspectral. Actually, we didn't use hyperspectral, but we use polarization cameras. But the challenge is that you would have to detect this in real time and give the feedback immediately so a robotic arm can go and pick that up. So this is an example of one real-time system in a thing. Second thing, there's an example of machine sensing. In people sensing, online shopping, we are actually trying to use eye gaze and other kind of wearable sensors data to actually predict when actually the person is on, the screen, when this is going into a click to the buy. If we can model this, so all retail companies, online companies are interested to do this. So that they can model, and they want to adaptively change the UI. That is the ultimate aim. So if you're not liking or something, how do you bring your attention back, dynamically change the UI? Amazon will do that slowly, and so that if they know this sensing part, they can model. So that part is still missing. So this is another example where, again, in a real time, you have to kind of do this kind of thing. You cannot afford to go back to the cloud to do this. Third one, clinical application. We are already doing this kind of thing with wearables. We are predicting heart health. And it has a lot of applications. One part of the thing is a more health screening kind of a thing that people We should predict, or like already Apple Watch also does that, you know that it tries to predict atrial fibrillation, other kind of thing. We have similar kind of a system which are trying to pilot within Indian population. But again, if you want to do this, it has to be privacy preserving, yeah, and it has to be done in the age. But you can analyze, so you get the ECG, you have to apply some kind of signal processing plus AI model on it, predict if there is a problem, and that has to be fed back to the user, or it has to go back to the doctor, either way, depending on what kind of application you are using. And finally, satellite. Satellite Earth observation today, the whole lot of work is happening on what I marked as a low Earth orbit satellite, or we call it LEO satellites. In that, all this kind of different sensing things are coming. Earlier, it was only camera, but now hyperspectra, many other synthetic aperture, all these different things are coming. But the problem is, earlier satellite used to just was it gathering data. And when it used to fly over the best ground station, it should bump everything there. Now we don't have bandwidth. Earlier, you were just sending monochromatic images, was of very low resolution. Now they are sending HD resolution RGB with a hyperspectral, with SAR. And your bandwidth is spectrum is limited. So they cannot send it back. Now you have to do it back to the satellite. And problem satellite, if you do satellite in the night time, it has no power. It is only solar here. So how do you conserve? So these challenges are coming. So a satellite also is a very interesting edge device. That's what I want to tell. So I'll just give a simple example. So effectively, what is happening now? A bigger part of this, and this is a sustainability story that is coming out here, is the energy cost of AI. It's very little talked about, but very recently, I think MIT has brought out the first report where they're trying to quantify it, and it is actually very frightening if you see these figures. So IBM Watson consumes 85,000 watts. Okay. GPT-3, we talked about ChatGPT is on GPT-3, yeah? Training 28,000 kilowatt hour energy consumption. Okay. Just average US household energy consumption is annual 10,650. And this is 28,000 daily. Imagine. And we are talking about EVs, and this is a much bigger pollutant that is going to come in because of this. So we have to be careful about this part, and same for the data center. And there's a cost to the environment. Like there was some example that is there that this BART is another transformer engine like ChatGPT. Training of that has a carbon footprint of roughly 14,000 of CO2 equivalent, which is a round trip Trans-America flight for one person. So that is the carbon cost of AI. So I'm telling, it is not only about a battery constant device where the energy is important. Even on cloud, 5 years down the line, nobody will be allowed to spend that kind of energy that is getting spent today. So you have to work with small models. You cannot afford to go for large models. How do you do that? So there are multiple approaches to do that. One part, I think a lot of work is happening on creating AI chipsets, which can do in a hardware, they can do the deep learning. And that's why, because hardware, it is low power, but it's not low power to that level. I think what we have to focus on, can we actually make the model more efficient? Because I'll tell you why this is important. Like, suppose you have 10 unknowns. We have seen that our high school mathematics tell us if I have 10 unknowns, I'll have 10 equations to solve it. Isn't it? Suppose I give you 10,000 data points with those 10 variables and 10,000 equations. The same thing will solve for 10,000 parameters, isn't it? It will solve. That's what is happening in deep learning today. I don't know what is my number of variables. I give it one, ChatGPT has how many? 1 billion parameters to solve. But who told you that my input model has so many things? And that is the, I would call I think we have to, it is always kind of oversolved. So there is a scope to reduce. So this is one approach that we are trying to take. Can we actually solve that part of the thing? And how do you do it? So there are multiple ways to handle it, but because I'm just introducing this, and you can think of as a new research topic that we should actually look at. So one part is I can actually go on pruning. And you know, pruning standard way, it is that normal pruning in deep learning networks, it yields around 3 to 5 times of reduction in size. But this new concept comes, and MIT has proposed, is called LTA, lottery ticket hypothesis. What they're trying to do, they're actually doing they're using AI to do it. In the sense, they're trying to go see which of if you have a network, AI deep learning or network or machine learning network, you can remove weights or connections in that and see how it is affecting the output. If it is not affecting, you keep that. If it is affecting, you leave it. So, and if you go on doing it in the whole way, in a very, I would call, it is a very complex optimization problem. If you solve it that way, we are seeing you can reduce it by 150 times. So this is one example that we actually did this ECG, same that I was giving the example of ECG. I want to detect that atrial fibrillation on my smartwatch. The original model was 50 MB. Not only that, 50 MB, it was expending battery. Like if you do it, maybe in 3 hours, the battery will die. Nobody will accept it. We have actually reduced it by 140 times by using this method. The memory. The memory from 50 MB has come to 300 MB or 250 MB kind, 250 KB kind of a size. And the power energy has come down by, I would call, around 100 or 500 times less energy consumption. Now it can, I can put in my watch, because now I don't bother about the 3 hours. It will go to whatever number of days. So that is the kind of, I think, impact it can make when you do this kind of thing. And the other approach is I would call LTH is, I would call, a more brute force approach. A more scientific approach is I do the other way. Instead of cutting the network, can I build the network? Can I start from zero and go on connecting, like, one layer with one multiplication and one neuron, then 2 neurons? Can I go on building it? And somewhere, what is the bare minimum I can go to reach the same accuracy? So this is the approach of what we call NAS, network architecture search. And the core thing that is going to happen, which we are working on, we are actually integrating LTH and NAS together, and we are getting excellent results now. If you do, no, it is something like you attack the problem on both sides. One way you start chopping, one way you start building. And you hope somewhere they will meet. And they meet, actually. So we are seeing that. So this is the result. I will not go to the details of that, but effectively that example, 42 MB was reduced to 300 KB with less than 1% accuracy loss. That is the key. And we have some interesting papers there when working with ISI on that. And so I will just I'll finish with these 2 future work, which I think is going to change. These are the 2 disruptions that are coming in this area. One is neuromorphic computing, and other is the nanosensing. And that is what will change this way. So first I'll talk about the neuromorphic computing, why it is important. Because I think here most of us, these are all electronics background, most of them. So you are aware of von Neumann architecture, isn't it? So what is it? What is von Neumann architecture? Anybody? Or everybody has forgotten? So von Neumann architecture of microcontroller was where you have your CPU and memory connected over a bus. So you have millions of computing elements in your CPU, you have millions of your memory in your memory, and there's a bus, and you're connecting. It was okay for traditional programming. When you do AI, what do? You basically do multiply and add, multiply and add, multiply and add. So every time you do multiply and add, I go to memory, fetch 1, multiply, go back to memory, add it, come back, add it, get back. So I do only 1 multiply and 1 add, and for that I may be going back and forth in the memory for 6 times. And this going back and forth in the memory part is what hits up your machine now. It's not the compute. So the memory access is what is giving you the hit today, more than the compute part. So neuromorphic architecture is telling, like, but the question is, in our brain, we spend only 20 watts. So the job which is actually now taking megawatts for NVIDIA GPU. Same job. Why? Because our brain is neuromorphic, where actually the concept is 1 neuron is 1 compute and 1 memory co-located. And you have millions of such compute connected. Now you see the difference in the architecture. Earlier you have all compute in one place, all memory in another place, and you have a bus to thing, and that back and forth. Now every neuron has a memory and a compute. And then, so this is the neuromorphic architecture. And First part. And the second part, what is happening is our brain works in spiking domain. Like when I'm seeing you, first time I see your full picture. Next time I'm just seeing the delta. And only the delta goes. It delta generates a spike. So now this concept of can I actually create a spiking sensor? You have heard of DVS cameras? Event camera. So you can actually create a sensor which can actually sense this delta instead of the first thing. And then I can build a neural network which works on the spikes, which is called as spiking neural networks now. It's SNN. You can search for it. Is the next, I would call this is the, they are calling it the 4th generation neural networks. After deep neural networks, SNNs is the next part. And there's a different way to train SNNs. So this is the part we are trying to do. So one part is Intel is investing heavily into it. There's a chip from Intel called Loihi. It's still not out in the market. Only have research access to it, but it will come out. So Loihi is the first neuromorphic chip Intel has brought out. And there's a company called BrainChip in here. So Silicon Valley, they have also brought out the first chip, which is available commercially today. So we did this work with BrainChip together, which was published in NeurIPS, where we actually controlled a robot using a neuromorphic controller. And the beauty is that whatever you do here, the figure you can think in the below part. The energy consumption is 35x to 230x less. If you go to the neuromorphic chip and do the same task using SNN, and theoretically, the people are claiming even 1,000 times less compute power. So this will be the future of low power computing. And we're already proposing this to our, I think, some of the startup partners and go through ISRO now to put this neuromorphic computing. We already have a cloud detection algorithm and a compression algorithm for satellites, which we think a neuromorphic processor on the satellite will be a great thing to have because it will extend its life because it is not, the battery will not go and I can reduce the data there. So that kind of thing is really coming up. And so this is one example. And the second example is where actually we mostly will be start working on IIT Jodhpur also. And the second part that is going to come in is what we call as a AI-driven nanosensing. So the problem, what is going to be the why it is AI-driven, and that is where I think TCS as a software company is, we see the opportunity. If you see a normal sensor, when I actually have a single biomarker, one sensor and I build one nano sensor to detect it. Very high sensitivity, high specificity, it will detect. So I have a carbon dioxide sensor. It detects, it picks when there's a carbon dioxide. I say I have a nitrogen sensor, it picks when there's a nitrogen. Now I actually have a system, usually, which will be there. I have an unknown mix of carbon dioxide and nitrogen. Unknown. I don't know it. And that is the job of this system. That's the inverse problem. I have to find out how much this and how much that. Both sensors will spike. So normal pattern recognition, which is in the top, cannot detect. So you have to have complex AI pattern detection algorithms to do it. So that is the view that we have to see. Now the challenge is, that is good. I'll build nano sensors, and then where do I put my AI? This AI will be required. I cannot put it in the cloud, forget it. In the edge also, can I build a nano sensor and put it in a microchip? It doesn't make any sense. No? So I think the future is, it will be a, this is my, I won't call this, may not come true, but I feel that it will be nano followed by neuromorphic. This is the next future of intelligent sensing devices that is going to come. Maybe it is 5 years away, but that is where it is going to go. We are doing some work in IIT Kharagpur. We are trying that they are building this thing that we call as a human VOC sensor. We are trying to detect the human breath and try to predict diabetic, because diabetes has acetone and a few other gases. We are able to getting a good there. And anyway, IIT Jodhpur, we are trying to go for this patch for sepsis detection kind of application and many other things we are thinking. But everywhere this architecture will become that way. So the key learning is definitely working with real-time problems, and data annotation is a challenge. We have to figure it out. And what is the frugal data system business driver? You have to figure it out. But I think the future challenges, these are all on their own, a research topic on their own. about I talked about only about inferencing, but how do distributed, federated, self-supervised learning? Because nobody is going to annotate. Now, the challenge is when you actually do it on edge. Cloud, it was good that you send the data on cloud, then somebody sits there, annotates it, becomes an open data set, you work on it and write 10 papers out of it, fine. Here in the edge, the data is coming, who annotates and who will, on the fly it has to do. Na? So effectively, it has to do self-supervised federated learning. It's not solved today. Privacy, security, bias, liability, not solved in any IoT systems. Here it is bigger. At least when is the cloud? It was there in the cloud. At least you could have put the liability on a human being. Here there is no human, autonomous. So is the robot will be liable, or if something goes wrong, or say watch, smartwatch, I predicted that a heart problem is there. It was not there, and somebody sued. Or the reverse, it was supposed to predict, could not predict. So who will be caught? The watch manufacturer, or the person who wrote the code for that AI, or the person who actually built that neural network architecture? Nobody. So how do you put your liability in this kind of autonomous intelligence systems where there is no human? Okay. So all these issues are there, and as I was telling, the nanosensing and neuromorphic will be the way to go. And I'll end. So I think these 5 books is something I am deeply influenced when this story is evolving today. Read these 2 books from Yuval Noah Harari. Starts with Homo Deus and this 24 lessons for 21st century. It actually talks about how this is moving towards age in a historian's language. It's not technology language, but it is a historian's language of telling how we are moving to the world of age. Life 3.0 is Max Tegmark is an MIT professor. He's told that Life 1.0 was the internet, pre-internet life. Life 2.0 is the social network-driven life of people. And Life 3.0 is where your social network is machines, not people. That's what he's predicting. So everybody will have their own network of machines as their thing. Deep Medicine is the book by Eric Topol, which is for the healthcare. He's a Stanford professor, and he's a cardiologist. He talks about how medicine will change with AI. And if you want to understand this spike, you should read this book, Spike. So it actually tells how brain works, the model. And that is the basis of neuromorphic computing is from here. And that will end. So as I told, the 3 books was there, IoT and Twin and all this, whatever I talked, many of these things are there, and some of the IEEE, I wrote in some of the IEEE newsletters, these 3, where we talked about first cognitive IoT system, then how to use it for health and for people. And very recently, we wrote about this age, why tiny age will be required. Okay, so with that, I'll end. Thank you. Any questions? Okay.
Thank you so much, Dr. Pal, for such a detailed and very intriguing talk. All right, ladies and gentlemen, we now move on to the panel discussion on how to strengthen industry-academia cooperation towards futuristic innovation in addressing practical challenges. Now, joining this panel, I am very deeply delighted to welcome Dr. Abhilasha Gaur, who is an accomplished professional with vast experience in the skill development ecosystem. She is a hardcore management practitioner with 20 years of experience in business development, execution of government projects, and implementation of various initiatives in skill development, corporate, and academics. Dr. Gaur joined Electronic Sector Skills Council of India as COO and is responsible for overseeing the operations of ESSCI. And she works closely with its governing council on strategic issues related to the growth of the ESDM industry in India. We're delighted to have you here with us, ma'am. And also joining this panel is Mr. Amrit Manwani, who is chairman and managing director of Sahasra Group of Companies. He has worked with multinational companies like L&T and General Electric for 20 years before he began his entrepreneurial journey. Since then, he has been in electronic hardware manufacturing and he has several awards to his credit from government and industry associations, including Excellence in R&D and Export. He was recently appointed as Chairman of Electronic Sector Skill Council of India that works in conjunction with NSDC and Ministry of Skill Development and Entrepreneurship. It's a privilege to have you here with us, sir. Also joining this panel is Professor Ajay Agarwal, who is Head of Department of Electrical Engineering. And now I invite Dr. Suchetna Chakrabarti, Assistant Professor, Department of Computer Science and Engineering, to moderate this panel discussion.
So, very good afternoon to all of you. And I'm so thankful. And it's super excited to have you here. It's our privilege. And we are having a wonderful session over here. And this past few talks, we could enjoy. And this was a lot of pointers that our audience can take home for for thought, over thought. And now we are here to have a discussion on this very specific theme, that how the industry and academia can put their hands together to meet the gap that we are having in innovation. So first of all, we need to understand that these all innovators, the scientists, researchers, our objective is to design, develop the systems which can have some impact in the society and on people, which requires this translational research. And for that, our perceptions are very different, and that how we think from academia and how industry experts look the problem. So there is obviously a gap, and that gives us the opportunity to explore the area in a better way. Sensors and IoT, fortunately, is a space which has this lot of potential. It's a vast pipeline that we can touch, from manufacturing to design to packaging and to the applications, AI, ML, Edge, a lot of scope. And with this interdisciplinary approach that we are taking with visionary leaders and this wonderful dynamic this workforce that we are having in IITs, we obviously can reach there, but we need to know about more details, like what can further be expanded for a sustainable relationship in future. And in that regard, I would first like to request Professor Ajay Agarwal to present that research snapshot of our activities in this very specific theme, what we are doing in IIT Jodhpur, and which will give a brief understanding of our standpoint. And with the interdisciplinary approaches, the curriculum which has already industry immersion, I believe we could reach that point pretty soon.
So, thank you, Suchetna, for a wonderful introduction. It has been an opportunity to conduct one of these verticals in this industry industry days. In fact, an industry day is what we are celebrating for the first time. And we found that sensors and IoT is one of the important area. And the responsibility we have taken both, and we are in slightly different areas. I work in the sensors development, micro nanotechnologies, and my colleague Suchetna is working in the system development. So that way we were complementary in this. And before I move forward, I would like to thank all my guest experts, industry experts, who could take time to come to us and tell us what is important in the industry, what's going on in this area. So a lot of takes are there already from the first two talks, and we would go further. So I'll not spend much time here, and I'll quickly go through some of the things what we are doing. So as already mentioned, the objective of this industry day has been to identify industry relevant problems so that we as the faculty members or students can work on those problems. We are in big way emphasizing on technology translation aspects when we are developing technologies. High TRL levels should be obtained at the end of the research work when we do this translational research. And industry association should be there. That is one of the objectives from the very beginning of the problem when we start. So that is a vision of most of the projects when we start here. Another important aspect what we are considering in our research and technology development is sustainable business models, and especially the students and faculty involved in medtech area, they are very much into this particular aspect of sustainability of the business model. And we are looking for strengthening of our relationship with the industries. So these are some quick objectives for what we have been organizing this event. When we say why we are doing and how our institute is facilitating, so I'll say it was also mentioned in the morning by Professor Chaudhary that we have interdisciplinary research program, and this program has 6 verticals, but 2 verticals are very much relevant to this theme what we are talking at this moment. So one of the themes is IoT and applications. The other is smart health. I'm putting smart health also because it is an intersection of lot of micro nanotechnologies and sensors, but there are many other aspects also, but we are using there. Other big initiative of IIT Jodhpur is in the area of IoT, AIoT Innovation Hub, which is being established here. It is being established. So we'll have our next session in the Fab Lab, what we are establishing here. And you can have a glimpse of what kind of capability we are establishing, how it can be used by our industry partners for their prototyping and other research applications. So these are just a glimpse of what we are establishing. We'll see in person also. And users are many, just to name some of these. So medtech, medical technologies is one focus area. We do some fundamental research also. So definitely our scholars and our faculty members can use these facilities. Skilling, startups, industries, and different kind of industries we want to associate, and some of them are already associated with us in some of these ventures. So coming to the core sensing, it has been already emphasized, and we do work in the materials area. There's some glimpse some of our students have given, our faculties have given yesterday to Dr. Ashwani, because he could reach yesterday. So we are into different kind of materials, and we are working some of these materials which are relevant for our application, like the sensing and other aspects. We are also working on different sensor platforms and which are being exploited for different applications. So we'll just give a glimpse of. And system level also, we have different capabilities and some of the areas we have just listed here, but we are working on when we are looking for sensor systems, affordability and portability, these are also there, apart from what Dr. Arpan also indicated, that edge computing and other things, AI at edge. So those things are at our discussion also, and we are trying to implement, and we need to learn more how the system is more useful for the industry relevant. I'll just take some use cases. I'll not go in the details. We'll discuss more in our next session, and we'll see some work being done in this area. So early diagnostics, these are some nano sensors or trace level things, real-time emission monitorings, remote monitoring and assessment of engagement, in the online meeting attendance. So these are some examples what some of the projects our teams have accomplished here or are going on. Like predictive maintenance and the quality control in the industry. So those type of projects are being already taken up, and there are some good results to show. These are some of the just glimpses. I will not go in there. So 2D materials, there is a good research and good knowledge exists. Borophene is one of the examples of the material, and it has a lot of capabilities, and some exciting capabilities exist, and we are exploring multiple applications for this type of material. In molecular diagnostics, diagnostics is one aspect. Another is prediction, and we are working on invasive and non-invasive ways also. So non-invasive ways are very exciting for prediction, early prediction point of view, because you can do a screening of large number of people using these type of sensors and systems. So for example, like sweat as a sample is being now used for some investigation purpose, and this I am showing some of the just some output results, and where we can distinguish the outputs, and I am not going the details. We'll discuss again in the next part. But using AI techniques, we can distinguish trace level molecules in many applications. This is just a new work started some time back. So our wearable clothes, and it is not having electronics, but using some conducting yarns, some sensors are being developed, and which can go even for the, so it is showing like the moisture prediction. So there is a crowbar is in the field. So it has those sensors on the body, and it is monitoring the humidity of the environment, and it is just giving the signal to the farmer directly on his mobile phone. Or a diaper is having a sensor, and when it is wet, maybe a baby's diaper or adult diaper, so message can be given to the attendant. So that type of applications now we are exploring. In the another system, this is an interesting team working on coliform sensors, and it's an electrochemical sensor, and we'll discuss on, and we'll try to demonstrate also some of the capabilities. IOT and HL for ubiquitous system design, which are having multiple applications again, and we'll discuss on these aspects in the poster presentation, other things. Pervasive learning of human activities through ubiquitous sensing is another area where we are working, and different activities we are recording through different sensing applications. So this type of some of these glimpses, activities we are doing. This is about the predictive maintenance and the quality control in the industry, one activity. If you see the collaborations, we have a number of collaboration in this particular space also, national, international, and more are in the university collaboration aspect, if you see. But we have some industry collaborations, and we want to build more collaborations here to take up more projects. So these are more where we are doing some projects at this moment. Thank you, and let's explore possible synergies for working together. So I'll stop here, and Suchitna, you can take forward.
Thank you. Thank you, Professor Ajay, for nicely summarizing our activities from IIT Jodhpur. Now, regarding our industry academia collaboration, what potential we have and how to move forward toward that direction, I would like to request Shri Amrit Manmani to kindly share your thoughts and give us some ideas.
Yeah, good afternoon, everybody. My photograph was shown a little earlier, but the name of the company was wrong. So, it was spelled wrongly, with Shashra or something like that. It is not that, it is Sahasra. And why we gave that name Sahasra was because Sahasra is a Sanskrit word which means millennium. And since we started our first company in 2000, year 2000, rather than call it Millennium Electronics, we called it Sahasra Electronics. This morning, actually, Dr. Ashwini Agarwal told me that Sahasra also has another meaning. It is one of the 7 chakras in the body. And this was just off the cuff point that I wanted to mention. Earlier in the day, we heard from Dr. Ashwini Agarwal and Dr. Arpan Pal, very energetic, very informative, talk. I wanted to focus more on the Indian industry perspective and the Indian market perspective. If we look at the global demand for sensors, it's about $190 billion as of the last year figure that had come out, that is in 2021. And that is expected to reach to about $345 billion by 2028. So it'll almost double in the next 5 to 7 years. The main usage of sensors is in electronics. 60% of the global demand comes from the electronic sector, and automotive and industrial combined represent another 14%. Compare it to India. The Indian demand for sensors is merely $5.6 billion, or about 45,000 crores in rupees. So that represents only about less than 3% of the global demand. Going forward to about 27, 28, that would increase to about $12 billion, which converted into Indian rupees would be a little over 1 lakh crore rupees. And there, we would represent probably a little over 3% of the global demand. So evidently, we are way behind in terms of usage of sensors in India. But the sad part is that none of these sensors, whatever the demand is, as of today, 45,000 crores, or going up to 1 lakh crores, not a single sensor is made in the country. It's all imported, and typically it is imported from countries like Japan, Korea, Taiwan, some from Europe, some from the US, a lot from China now because of price competitiveness. And right now, we do not have any ecosystem for sensor manufacturing in the country. If we look at, I will not spend too much of time on this, but again, here also in India, 62% of all sensors are used in electronic sector. And even in electronics, bulk of it is used in consumer electronics. And when we talk of consumer electronics, we immediately think of wearables, hearables, etc., etc. So clearly, the desire would be to look at electronic sector and the industry sector for usage of sensors in the country. I will not spend time on this slide. What are the industry segments? We've talked about electronics, and in that electronics, automotive, smart city applications, power, so on and so forth. And who are the customer groups? OEMs who make electronic products, end users like the people who use wearables and hearables, system integrators, because there are a lot of systems that require sensors. So system integrators and contractors are the major users, and of course, people who make panels for power electronics applications, etc., etc. Here also, a lot has been talked earlier itself, so I will not, spend much time on it. My previous speakers on the panel, they have already talked about the applications and different types of semiconductor sensors. But in India, as we see, if you look at the maximum application is in MEMS, semiconductor, photonics, laser, ceramic, and X-ray sensors. Who are the key stakeholders? As I said, a lot of sensors are coming from outside the country, and therefore the key players really are the channel distributors or sales representatives. And these companies typically through sales representatives influence the end users to buy only imported sensors. Some people, when they try to develop something locally, they are either not allowed because the specifications are written around imported sensors. So that is the sad story about the Indian situation. But we see a lot of large houses as the end users, again, Siemens, ABB, etc., or Schneider. They typically tend to buy sensors again from either their own manufacturing overseas, or they buy from countries like Japan, China. So where does that leave India? That's a very important point. And today, as I said, there is no ecosystem for sensor manufacturing in the country. With the demand growing in the country, it is just not sustainable that we continue to import from outside the country. It's not only true of sensors, but overall electronics. Ministry of Electronics has come out with a demand forecast that the Indian demand for electronic products today is about $120 billion. It is expected to go up to $300 billion by 27-28 timeframe. And it will exceed, the import of electronics will exceed import of oil bill. And that certainly is not sustainable. And that's why our Honorable Prime Minister is focusing on Make in India slogan. And he sincerely wants that we make all electronic products in India, at least have a zero-sum game whereby we definitely need to import components and some subsystems, but we must export so that we have a net zero effect. And how can we do that? Particularly talking about the sensors, the first step, if we could divide this into three areas. One is the design side of it, the design and development. The second is the fab itself, and the third is packaging of the sensor wafer. And then, of course, we go to systems and application in the industry. Some work is already being done in terms of system design around the sensors, various kinds of sensors. And as we did a market research. By the way, 5 of us, that is 5 companies who have been entrepreneurs in the country for over several decades. The CEOs of these 5 companies put together have about 200 years of experience and collective turnover of over 2,500 crores. We got together and we are trying to develop an ecosystem for sensors, particularly on the user side or the marketing side. And we are focusing on what are the major thrust areas where the sensors could be used, particularly for India-specific requirements. And we have narrowed it down to industrial usage, typically for pressures, temperature, and flow sensors. And we are conducting that market study, which should come out by probably end of March. But the point is, we have to take the next step. And the next step, which is an easy step to take, is developing packaging. Because we cannot talk of fab. Today, if one were to set a fab for sensor semiconductors, that would require heavy investment, and it'll take several years to come. The government of India is talking about fabs, semiconductor fab. No decision has been taken as yet, as we speak, but hopefully the decision will be taken in the next few weeks or so as to who's awarded the government aid for setting up a fab in the country. But even after that decision is taken, it'll take about 5 years for a fab to start giving product in the market. But where will that product be used? Where will the wafers be used? So, we have to, it just cannot be just simply said that, oh, we will export all the wafers. Why would anybody set up a fab here if one has to export? Then they would set up a fab where it is easy to do so. So we have to look at ecosystem for packaging. So that is one area that the industry should definitely look at packaging. Our company is setting up a ATMP plant for packaging. Of course, our focus is on memories, but we are also looking at other forms of packaging because the tools are common. Some amount of tweaking is required if you want to go from memory to sensors to other applications. But we are setting up that ATMP project. It's incidentally in Bhiwadi, Rajasthan, and we should go operational later this month. It has taken about 2 years for us to set up the project because there was a huge demand for semiconductors worldwide, and therefore the equipment delivery was delayed. I'm not talking about advanced material tools because in standard packaging, advanced material has very little to offer. We are talking about standard packaging, not about advanced packaging that Ashwini's company is heavily involved in. So ATMPs, there is a need for ATMPs to come. But the most important thing is we have to design the products here, design the sensors here. I recently was approached by a Taiwanese company where they came to us and said, India uses a lot of audio sensors. And where are they used? In wearables. And who is the biggest user of those wearables is 2 Indian companies. Apple is, of course, the largest manufacturer of wearables. And the second company in the world is Boat, which is an Indian company, and also Noise. So these people use a lot of audio sensors, and the total demand in the country is only next to the US. So there is a huge potential, and we were approached by this company. They had developed the sensor in Taiwan. Now, I immediately sat back and said, why can't such a development take place in the country? There's a huge potential, existing market, not a whole lot of super technology that is required. The people here in this room and elsewhere in the country, we have adequate capability to design audio sensors. Why can't we do it? Why do we have to depend on a small country like Taiwan with a population of 18 million, less than the population of New Delhi, if they can design a product that is required now? Dr. Ashwini Agarwal or Dr. Arpan Pal were talking about technologies which in India, in my opinion, are a few years away. Of course, they are doing wonderful work. But the need of today is standard packaging, standard technologies that we can easily produce in the country, and make India self-reliant in the sensor domain, at least for those products which can be used in India. the $4 billion market, or sorry, $5 billion market, 40,000 crore market, which is going up to 1 lakh crores. At least those sensors, at least 50% of it, if it can be made in the country, we're talking about a 50 to 60,000 crore market. If those products can be designed here, so, we can have a fabulous ecosystem for sensors. Design the product here, package the product here, and then, the system integration can be done here. Fab will take time to come. And here we are not even talking of advanced nodes. We are talking of very matured nodes. Not very, we are not talking about 15 nanometers or 12 nanometers, 8 nanometers or 3 nanometers. We are talking about 500 nanometers or minimum of 180 nanometers. So we have the capability, we have the talent pool. Unfortunately, all that talent pool, whatever it is, like Applied Materials or like Western Digital, or there are many companies in the country, MNCs, they are using the Indian talent. They are, designing the products here. What is happening, unfortunately, is all that IP is going into their countries, and then it is coming back as imports at, several X times. If you guys, and you are the future of this country, if you guys chose to design the product for India-specific situations, and the other thing, we've heard about the big companies, the Intels, the Advanced Materials, Infineons, ST Micros. That's fine. They will do their job. They are big. They will continue to, do R&D. I'm talking about the small and medium enterprises. Any country, including the US, the bulk of GDP comes from small and medium enterprises. Anywhere between 100 crores to 1,000 crores. That is the strength of India. And I would urge the youth of the country to join the mainstream in India. Have your startups. That's what we, five companies have worked together. What we will do is help in incubation, mentoring the startups, and create products which are India specific. That is all I had to say. Thank you very much.
Thank you. Thank you, Shri Manmani ji. That was quite thought-provoking and eye-opening at the same time. Realizing that this much prospect we are having and still there is this scope, this is a bit awkward for all of us, like why aren't we there yet? So I would like to request Dr. Gaur to share your thoughts on this, like what further can be done in this context if we'd like to really meet this gap.
Thank you, Suchetna. And I think the most toughest part of the day is after hearing for 2 hours regarding IoT and sensors, and then somebody asks you to speak on the same topic. But what Mr. Manwani was speaking, that there is no manufacturing, what is happening in India. I think these futuristic technologies, and I'm sure the day is not very far, the way the country is moving, when the ABCD changes. And when I say ABCD, I literally mean it. So A for artificial intelligence, B for big data, C for coding, D for data analytics, maybe I for IoT, and S for sensors, N for nanotechnology. Until and unless we start teaching them, because gone are the days when the alphabets were made, they were made because child was exposed to these things, apple, bat, cat, dog. But nowadays, children are exposed to another kind of technologies. I mean, once they come on the earth, they start getting in touch with these technologies. So I'm sure it will not be that difficult for the teachers to teach them regarding these futuristic technologies from the very primary level only. We are sitting at IIT, engineering college students understand that when we are talking about chips and wafers, we are not talking about Lays. But most of the students in the country who are studying in school, they still can't relate to it, that what we are talking about. So I think the topic of panel discussion which said that how we can integrate industry and academia. So my point of view is that integration has to start from the primary level. And by the time you reach at the graduation level, you should be exposed to all these technologies. It should not be the engineering college where you take admission and then you get to know about these things. Why not we start at the initial years of your learning? So what we are doing at Electronic Sector Skill Council of India, this year we are launching Electronics Olympiad. We all must have gone through that we have given Math Olympiad, Science Olympiad, English Olympiad. But now we want to connect with the candidates, the students, and we want to tell them that the computer science and electronics is different. The software and the hardware part is different. When you ask a student that once you'll grow up, which company you would like to join, and he might say Amazon, Google, Meta, or other companies. But if you'll even ask a class 12 students, can you name 5 electronic companies? I'm not sure he or she will be able to answer. If they'll be able to answer, they might be knowing only about the consumer electronics. Maybe Samsung, LG, Voltas, Godrej, but not the other manufacturing companies which are there. So when they'll not be aware about which manufacturing companies we have in India, how will they aspire that they want to join those companies? How we will get this workforce? The food for thought what Mr. Manwani gave in his presentation, that why can't we do it in India? So let's go and tell the candidates that this is also an aspiring sector. And when we know the government of India is giving so much of emphasis on Atmanirbhar Bharat, on Make in India, it means definitely India will become a manufacturing hub. And once we become a manufacturing hub, should we import the workforce from other countries? Because right now we are exporting the human capital to the world. And we want to be the skill capital of the world. So I think it is very, very imperative that this education should start and the integration should start at that level. If I talk about sensors, maybe few years back, I would have not imagined. In various forums these days, we are talking about Amrit Kal, Amrit Pidhi, what Nirmala Sitharaman also mentioned 2 days back in her budget speech also. So we're talking about what India needs in 2047. Forget about 2047. If I talk about 2023 also, I never imagined that while leaving from my office in the evening, I'll be able to do half of my jobs before reaching home. Maybe I can set on my AC, so by the time I reach my home, the temperature is set, the kind of lighting what I want, so that I don't feel that I have to open the door, switch on the light, and I feel okay. I just entered. Maybe as per my mood that day, I can put on the light. I can ask my Alexa or Echo that what kind of music I would like to hear once I enter my house. I can start my microwave or my washing machine, and I give my instructions to my refrigerator also. So this is 2023. We are talking about 2047. If this is what is happening in the manufacturing industries, what you saw in the TCS research presentation, that what is happening in the manufacturing, and I'm talking about my personal life also. And I'm sure you all must be using these technologies where Dr. Ashwani talked about a robot also for cleaning the home. So in one or the other way, we are seeing these technologies definitely. But are these changes coming in our education system in the same pace? Should we celebrate Industry Day once a year? Maybe you belong to a creamy layer because you are with IIT. But think about those colleges who are still studying the same subjects what we studied 20 years back. So the change has to come, the integration has to come into education and industry. One good thing, NEP 2020 has already been announced. The colleges have started implementing it. And they are very good things. It's a good 200, 300 page document, but whenever you get time, just download it and just read it. As a young youth, when we have the demographic dividend in the country, and when we want to rule the world, where our average age is in 30s and the rest of the country's average age is in 40s, the next 15 years will be very, very crucial for India. And if we are not able to get this opportunity, if we lost this opportunity, then it is everybody's loss. It is the country's loss. I don't know how many of you have gone through this NEP document, but you are the one who are taking education. You are the one who will be joining the workforce. If we talk about the generations, we picked up this concept. Now I'm not talking about sensors because we have heard a lot of things about sensors. So I'm just talking about integration of education and industry. And it does not matter, it is IoT, sensors, semiconductor, PCB design, industrial automation, robotics, EVs. It can be any industry. Because IoT and sensors is pervasive. It is everywhere, in whatever field you go. Even if you go to a leather manufacturing shoe company also, they're also using sensors. So it does not matter that which industry you will join. But just read that what country wants from you. Just go through the national education policy. And then you will be able to even ask your institute also that this is what the nation wants and this is what institute is delivering. If there is any gap, why the responsibility is only on the management and the faculties? Why can't students can also take up this challenge? And as an institutional social responsibility, I must appreciate the efforts what IIT Jodhpur is doing as a knowledge council, what they have created in Jodhpur, even AIMS and MedTech. Because even in MBBS, don't you think we should have a subject on AI and data analytics? Everybody has spoken about wearable, hearables, even when one of the previous speakers spoke about maybe by analyzing breathing, we'll be able to detect diabetes. What about that doctor who does not know how to analyze this data? I'm not sure. Have we made these changes in the syllabus for MBBS or not? Or do they need to complete MBBS and then they have to come for a medtech program? Or one more subjects can be added then and there only? So I think these are some of the things what we need to think about. Next is what kind of jobs which will be coming with these kind of technologies. What we are doing at Electronic Sector Skill Council of India, we were made 10 years back by Government of India with Ministry of Skill Development. And we were told that we have to fill the gap between the industry and the academia. So around 17.5 lakh candidates have already been trained and certified in various job roles. But those were mainly for you can say the technician kind of job roles. But now definitely the focus is changed. And now we are focusing on students who are undergraduates and even postgraduates also for higher level technical job roles also. I don't know how many of you are aware that you must be watching Olympics. But do you know there is Olympics of skills also? And India participates in that Olympics of skills, and we call it World Skills. More than 50 countries participate in World Skills. 2019, India was ranked 13th when India participated in this competition, which happened in Kazan, Russia. So this year, 2022, last year, it was scheduled in Shanghai, but due to COVID, it got postponed. And it happened as a special edition in 15 countries. Most of the competitions happened in Europe. And India got 11th rank. India got 3 silvers, 2 bronze, and 11 medallion of excellence. From electronics also, we got bronze medal in mechatronics. We got medallion of excellence in mobile robotics. So as a student, I think my last take on it, that the 5 E's, which are very, very important for you. First is explore. Explore what is happening around the world. Maybe one of you can go and participate and represent India in these world skills competitions. The competitions are of various range: mechatronics, mobile robotics, graphic designing, web designing, water technology, even bakery, confectionery. Even the competition is there for bricklaying. So there can be n number of things. So first of all, you should explore. Explore who are the different employers who can employ you. Because I think most of you are from electronics. So look beyond the top 5, and I'm sure they'll be offering you a good package also if you join there. Next E is explore and then engage. As a Gen Z, the students, or the people who are born before 1964 are the baby boomers. Till 1980 is Generation X, 80 to 2000 is Generation Y, and who are born after 2000 is Generation Z. I don't know who named this generation because it happened in US, X, Y, Z. Now people who are born after, let's say 2020, because earlier generations were changing after a gap of 20 years. But now the generations are changing, I think, every 5 years. Or max, if we put 10 years, we don't even have a name for the next generation. Millennials. Alpha. So we from Z, we go again to alpha, and then maybe beta, Charlie, delta, eco. So that way is what we have to do as Gen Z, because the last generation, which was Gen Y, and on a lighter note, if I'll just ask you why it was Generation Y. And it was quite literal to its name, because if you'll ask anybody of Generation Y or even Generation Z also, come here, the question will be, why? Okay, get up. Why? Can you pick this up? Why? So it means you are looking to a logic in everything. So just engage yourself in the same logic from your personal lives to your academics also. So that is engage. Third is definitely education. So everybody from in India, from KG to PG. So parents make sure that you go through this education. So that is okay. Next is employment. Start looking for various opportunities, I said. And last but not the least is e-learning and entertainment. So we need not to be so serious. So I'm sure if you are in first year or second year, or even if you're final year, the time has not gone. You can always look forward. And I'm sure these kind of interactions, listening from the stalwarts from the industries, like last 2 hours, what you have been listening, and tomorrow also you'll be listening to various things. So just listen and try to imbibe those things in your life. All the best. Jai Hind.
Thank you, Dr. Gaur. As you rightly pointed out, engaging at the early stage has immense effect on everybody's life, and that's a very fruitful advice that we should all take away. So another point in this particular context that you were discussing, these young minds, the entrepreneurs, the scientists, the students who are going to be, are designing our future. So when they do their research at the very early stage, it's critical to select problem, and we kind of think that that's the most difficult part of their journey. Whatever research they are going to make or build the system. Now, while we are emphasizing on this industry relevant research, and the government of India is also giving a lot of thrust on this, and we have a lot of facilities to support our systems, right? So, like, I would like to ask Dr. Ashwini and Dr. Pal, so what piece of advice would you like to give our students as well as the faculty in order to do this kind of translational research and to pick a problem which is industry relevant.
Okay, you already said industry relevant. Start with your faith. Okay, you should believe in what you're doing. Start with your end customer, the end market. After 30 years in the industry, I learned that what I learned in MBA 30 years back is absolutely right. You start with the customer, you'll never go wrong. So please define your problem statement with reference to an end customer. And when you do that, you will actually find the answer to his requirement, and that will build value, and that will pull you into your translational execution.
Yes, so I'll just extend to what he was telling, and I will try to focus on, say, the two parts of the work I see. So one part of the work is more, I would say, there's a current problem, and you go to the market, see that problem, and go and solve it. So obviously, there is this continuous kind of a translatory kind of a solution you can build. So I would say that there should be a large focus on that, but we cannot only focus on that. We also have to think about what is my next, because the IP content in that will be low. Because you are not actually doing the research first and then going there. So the challenge is now that how do you kind of do a research content and then bring it into the market. So the suggestion will be something like this. So you can actually work with industry to define the problem first. And there are
Engaging industry at the very
only
early stage.
so industry has two roles to play. One is to define the problem, another is to consume the outcome. So I'm telling engage with industry first, and especially the industry labs and R&Ds. If you engage, you'll get a gamut of the problems which are industry relevant. Not now, maybe 4 years down the line, 5 years down the line. Pick up those problems, align that to your research agenda. Create IP out of that research. It has to be done. And then comes the next part. There was a big gap of once you do the research, how do you take it to the market? I think government has done an excellent job of, I think Professor Shantanu was talking about this, all these innovation hubs, TIH. TIH is the way to actually know, because the research, in our case, we tell that research is only up to TRL 3. If you have to go to the market, is TRL 4, 5, 6, 7, 8, 9. That journey is a very hard journey. It's not easy, that engineering journey and the market journey. So that journey of TRL 4 to TRL 8, 9 has to happen in the TIH. And government is giving large funding. And do that, and when you do that funding, I think the engineering part you can definitely do there, but the marketing part of it, that's TRL 7, 8, 9, when it goes to the market, sometimes TIH will not be able to help you. That is where I think you heard in the morning that talk of an entrepreneur. That is where I think you yourself has to become the entrepreneur, believe in what you have built, and then take it to the market. Build your own startup. So there are 3 phases here. 1, 2, 3 is research. Then 6, 4, 5, 6 engineer you can do with TIS today. I think the mechanism is existing. 7, 8, 9, I feel you have to create your own market. That is the startup part, and you have to go there.
Thank you. Thank you. Yeah, please.
Totally agree with you. So when I said that you should have your faith, you should believe in what your analysis of the market situation is. You should do your homework. When you start with that market, that application, and then link your disruptive technology to it, then the real reaction starts. You have to go through it to actually, understand what we are saying. Doesn't happen off the cuff. The reason is something that Dr. Arpan said. Something which there's a very famous quote by Ford that if I just followed what my customers wanted, then they would have asked me to build a faster horse and the car would not have come. So you need to have faith what you're working on, and then link it back to the application, understand the disruptive part of it, link it back to the challenge of taking it to the market. And as Dr. Arpan said, the greenfield research is TRL 1 to 3. The proof of concept development and polishing is TRL 4 to 7. 7 to 10 is where you are actually incubating in the marketplace. You're polishing all the things you are learning is missing in that final execution. And you are polishing it up to the stage that it becomes TRL 10. That means it's a stable process. Now it's literally, you can go to a disco and pick up a machine and bring here, and you are ready to go.
Thank you.
Just add one line, actually. The important part, what I see, that I think that either talking industry, academia, the change that I think the academia thought process that is to come in, I sometimes call it delta T and delta I. What I mean by that, academia, you always talk about what delta improvement you are bringing on state of the art in the technology. So if the technology is state of the art T, you build T plus delta T. But I think you have to start thinking what that impact will be in the market. So today, if the impact is I, what is the delta I? It may happen with a very small delta T, you can do a very large delta I. That is what will actually succeed in the TRL 7 to 10. But if you have a very large delta T with a very small delta I, and that has to be thought through when you actually pick up the problem, not after you have built it. Very important to think about that impact. What you're perceived, what you are changing, that change, how much impact it will make in the market. Either societal or business.
Right. And I believe like it's a huge responsibility on us as well, like to nurture that culture. Yeah. We have obviously a lot of facilities and exposure which actually enables industry immersion from the very early stage, all the courses that have this industry experts who can deliver lecture. We have this IDRPs which will enable say interdisciplinary research. We have TISC, we have TIH, right? So the students can make use of that very well. And I am obviously having a very interesting conversation with you all. And audience is also being engaged for last 2.5 hours. So in the interest of time, I would like to now stop. And before doing that, I would like to ask a few questions from the audience, because there was, yes.
Very interesting talks and discussions and all these happening. I was listening to Mr. Manwani, and he was talking about, not even single sensor is being made in the country. It is an irony. I was just trying to, understand the things in the sense that, today in the country, lots of groups are working on sensors. Lots of research is happening. Lots of resources are being put. Where they are going and how to, channelize them. Can there be any mechanism, or what could be? That's what my question or comment.
I'll give you the answer by giving you an example. Some time ago, maybe a few months ago, we were approached by the industry, the lighting industry. They had a problem. In the lighting industry, they were using a driver chip, which, a controller or a driver, which lights up the LED. And the price of the chip is typically 5 rupees. The country of India, and I'm talking about the demand below 18 watts. That means home lighting, lamp, tube light, downlighters, as you see here. The total demand in the country is about 120 crore units. So, that's the demand. All of that was being imported from China. What happened during COVID was, particularly when China was hit with COVID in a severe way, the price of that chip went up from 5 rupees to 9 rupees. That is not sustainable, because typically a bulb, at those volumes costs about 50 rupees, LED lamp. And to increase, add 4 rupees to that is not sustainable. So both the government became aware of it, and the lighting industry, of course, said what can be done. Now, this is a low-hanging fruit. We were requested, because we were setting up a packaging unit. We were requested what could be done. And our first reaction was, oh, well, we will not touch it because this is very low end and we are into memory packaging. So we first shied away from there. One of my, team members said, sir, why don't we look at it? We actually got that product designed here. And to my surprise, our price was far lower than what we're getting from China. Now look at the demand. Of course, once we start manufacturing it, the product has been designed here. We will package here. We don't have wafers being fabricated here, so we'll have to depend on for wafers to a foreign country. But those are the low-hanging fruits that we should look at. So similarly for sensors also, we have to identify that low-hanging fruit. To give you an example, of course, it is not the time now, but quite a few years ago, tire pressure monitoring. Look at the market for it. Huge market. Somebody could have thought of it, designed the tire pressure monitoring sensor. Demand is huge. Unfortunately, we didn't do much work. Probably it was done at the lab scale, at the research state, but didn't come to the market. When we develop a product, that's why it is very important for academia and industry to work together. You do wonderful research. And believe me, I'm from IIT Kanpur, and I have gone back to IIT Kanpur because, my alma mater. They do a lot of good research, but it remains there. Most of the faculty or the students, they are keen on going either overseas, therefore they prepare papers, research papers only for the international media.
So my question is simply that how do we come out of it and what could be the mechanism of doing so? Because we are putting a lot of efforts, resources, and all those kinds of things. How do you get fruit out of it? That's what my perhaps the question is. If any, may not be answer is here now, but then answer has to be in future. And we have to look at, as a community of sensor people or as a community of industry and all that, we need to see that how we come together and channelize our resources so that, whatever efforts we are doing, we are publishing great, we are doing all those things, but how to convert into, real uses. Sir, so answer may not be now, I can.
No, sir, the answer is very simple.
Yeah.
We have to build trust in each other. For some reason or the other, the three entities, academia, industry, and the government, somehow there was a disconnect. And that disconnect led to, working in silos. We have to integrate.
I think at this moment, I see on the stage, government is there, industry is there, academia is there. So perhaps,
I wanted to make one comment. That's again, I'm going back to the TRL example. I believe in the hardware space in India, we stop at 3. The effort to go to 4, 5, 6 has to happen. And it can only happen by the people who have done 1, 2, 3. Sometimes there is a tendency that you do 1, 2, 3, hand it over. No, I think that is a general. You in academia do 1, 2, 3, hand it over to industry. It doesn't work. All our successful projects, the same team actually went through the whole route. So that has to happen. I think that's why I mentioned the TIH and other thing coming in. We have to do that. If that happens, I think this will get more. In software also, we do go up to 4, 5, 6. We don't do 7, 8, 9. That's why I don't have Indian products. There's a problem. But still, at least the 4, 5, 6 is done in software. In hardware, you don't even do that. I think that is the change that has to come in.
I have a comment here. So when we say TRL3, so yes, that is a fact. In academia, there is no incentive to go further because at TR3, we are publishing, we are patenting also, and most of the time there is no support to take it further, and that is the harder part. So is our industry ready to take it further? Because industry has to pitch in. If something is useful for the industrial commercialization later on, so they have to pitch in and handhold these technicians or the scientists only, and then they can take it.
I think here I a bit disagree, because if industry says that no, academia, and academia says that is industry is ready, then I think this is where this industry day is. And perhaps on the industry day, I think we should be moving forward into, both sides, and we reach to a point where we get into these things.
To happen because it is our experience, because we are also in our company, we are like academia. I am R&D. Whatever you face for our business teams, no business team will take anything if it is not 6. Okay, so I think it has to be done, because if there's a ready market, it will be done. If it is for new market, unless you show it is working in that market at a proof of concept, nobody is going to put money. So that is the disaster. I think that is why I like this TIH model or any other where government is now funding translated research. That government is giving the funding. To do that, take that bet and then take it to the market. I think that has to happen, then some cases it will be there.
Perhaps we say that government should take steps to, is it that you mean to say?
It's already there today. I think this is already happening now.
Yeah.
This is started now. I think in next 1 or 2 years, we'll just see this happening in a more larger scale.
Okay.
The process is already in flow.
Okay.
That is a good thing.
Yeah.
See, I have a certain observation, I have observed something over several years, that one of the reasons why that, technology transfer from academic place to industry, that did not take place. What I think, as Dr. Dodpon told, that, you first go to industry, pick up a problem, do research, and then delta T delta, you told that how impact it can create it. I think one of the problems, what I consider, I am not very big collaboration with industry. I've done a lot of research in IIT, which are, internationally recognized. But what I think, that there is a basic problem, like I was talking to a few Indians who are professors in USA. They told that we have to struggle for, to write proposal, to get fund, because every project, every PhD, they have to fund from their money, the projects which they are getting. India, we have a luxury. The government, over the 30 years, all my students, they got IIT fellowship, means government money. And that is the reason that USA, or even in Germany, I visited on several occasions by invitation from the Alexander Humboldt Foundation, that each and every PhD thesis in German universities is an industry problem. So here, what I think, why that is not getting developed in India, the trend has come, except DRDO or space or nuclear few projects they are giving, that industry, our Indian industry, the R&D, is not that developed, most of them, the production. And once they come forward and they give the project, then that brilliant mind in IIT students, young students, they can work on actual problem. I think there is a gap on that. What is going on? Even I was visiting one of the top universities in South Korea, KAIST, Korea Advanced Institute of Science and Technology, in 2007. And they were talking on the touch screen. And after, mobile. That time the mobile was of Nokia's, all set. And then after a few years, the entire world mobile they have taken. And then I see in the KAIST, every lab is LG lab, Hyundai lab, this lab, Samsung lab, all labs are funded by the industry. And the students are, PhD students are working, and they are trying to make something new, which is useful for the country. They told the 1950s, our salary, professors were telling, much less than the Indian professors, $100. But only by work, 5 crore population, 70% mountain, 30% land, they have done miracle, and they have technology, they have soul, and they have become richer than India. So this is my observation, that Indian industry and academia, academic institution, more that way collaboration. They should come out. I'm not blaming industry people. Academic also, they should go to industry, and industry should come forward, and they should fund each and every PhD, or at least 90% PhD or 80% PhD fellowship. Then that technology can go to industry, and our Indian industry in production, in terms of, because software something is done, because only the brain is needed. But the production, the technology absorption is there in India. But I think the technology production, what we lack from China, South Korea, Germany, all these countries. This is my
Yeah, so clearly the message comes out loud and clear. It has to be a two-way street between the academia and industry, and the government has just to play the role of an enabler. That's all. Government should not intervene beyond that. Government has come out with beautiful schemes like the design-led incentive scheme and all. So they have become enablers, and they've done a wonderful job over the last few years. It is now for industry and academia to work together. That is very important. That's my.
Yeah, thank you. Any other questions? Yes. Maybe the last question we can take from this session, and then we will take it outside during the break and the poster interactions. We can have it. Yeah. Just the last question.
Yeah, so I think this is already a problem that everybody in the AI world is picking up, because what happens is you train your intelligence on some sensor data and the sensor starts drifting. But today I think technology is there. I talked about self-supervised learning and other things. These are actually there to pick up those sensor drifts and automatically retrain. And this is already happening. So picking up the sensor drift, sensor drift can happen. The problem is it is a normal cases that value change may mean some abnormality. But in the drift, it may be the normal. But drift will happen not happen in an abrupt way. It will go in some kind of a smooth way. And that pattern now AI models are being trained to pick up. So this is a problem, is a well-known problem today now. And there are being solutions being designed.
Thank you. Now, to summarize this discussion, what we can take away, like I will emphasize on 3 points that we have learned from this discussion. You start early, have the exposure of the world problems that you are living in at the very early stage, involve in like what's going around, the do the product and the market analysis at the early stage, choose wisely. So while choosing your problem, it has to have some relevance that are going to impact the society, all the the well-being of the human being in any way. And that is where it has a huge responsibility to collaborate with industry and get the problem straight. Otherwise, the interest won't also come, because it's a win-win situation for both. And third one is aim high. So aim for higher TRL. So as of now in the academia, there has been this practice of more like paper-oriented research, and from where we have to go forward towards building up products and aiming for higher TRL. So that is again another challenging task, but not impossible. So that's where I think we can conclude. And I would like to thank you all for having you here and spending wonderful time with you. So we'd like to know more on this topic as we proceed for our poster session. Thank you all.
Thank you for that insightful session, and thank you, Dr. Suchetna, for moderating it beautifully. And our sincerest thanks to the distinguished guests for the day, and also all the guests outside of IIT Jodhpur who have joined us here. We're really grateful for your time, and we are resolved to take our research further, and we're looking forward to more collaborations. Thank you all for joining us today. We do have tea and refreshments for all of you outside of this auditorium. So please join us for that. And after that, please proceed to the AIoT Fab Lab for a lab visit, poster presentations, and networking. Thank you very much. I'd like to request Professor Vadera to give away the memento to our keynote speaker, Dr. Agarwal, as a token of our appreciation and thanks. I'd also like to request Professor Vadera to give away the memento to Dr. Paul. Thank you, sir. Thank you, Professor Vadera. I'd request Professor Ajay Agarwal to give away the memento to Dr. Abhilasha Gaur. And I'd request Professor Agarwal to present the memento to Mr. Manwani. Thank you, sir. Thank you, everyone, for joining us. Please head over to have some tea and refreshments, and then we'll all proceed towards the AIoT Fab Lab for a lab visit. And there you'll find a lot of posters as well. Thank you so much. Jai Hind.
useful to me, to creating a business for me, repeat is happening. Finance it. And that's where various applications coming, various website. Despite this, I think Corona pandemic has made things much simpler for your generation, where many things turn digital forcefully by environment. In smart mobility space, this is where we are doing. Fire brigade, dial 101. If you need ambulance, dial 108. Now, across India, a standardization has happened. Pune, Noida, Ludhiana, and means to our economics out of it. It is a mission mode project of Government of India, where every Gram Panchayat level, government wants to lay out a optical fiber network. A 100 Mbps speed optical fiber network being connected up to every Gram Panchayat. this project, and then I will take you into the technicalities of this. We have won a number. So here how I get penalized, because it is totally outsourced to Tata Projects. So my SLAs are very. There that time is 30 minutes. But even there, Google Maps doesn't give the right direction. ICT part is very complicated, though it sound पुलिस की गाड़ी जा रही है उसमें क्या लगता है. So we have a call initiates from somebody. The telecom operator provides its GPS location into my call center. The operator see on his ICT screen where the call is coming from, and we have 250 vehicles deployed on the road. Which is the nearest vehicle? It is already in service or it is available. Then the call center talks to the driver in the vehicle, and he got a tab device where his availability is confirmed, location is fed to him, and like you get on Ola or Uber or Google Maps. Similar, where he need to drive and reach to that is response system, and it is 24/7 in 3 shifts, 250 vehicles running around. That is kind of service. And we get paid monthly for that kind of service based on if there is SLA is not followed, there is a steep penalty to the operator like us. So we maintain a good satisfaction ratio of 97%, ERB availability of 98%. Current call volume is around, we get 7,000 calls per day in the call center. And after talking to the person, we decide whether a vehicle should go, or ambulance should go, or a fire brigade should go. And finally, at least average 1,000 calls are serviced where vehicle reach to the endpoint. That can give you the complexity of this one. Let's go to another LED project. Giving example from Nashik Smart City. Should volume be increased a little bit? So similar to this, we are reducing. That green, apart from these are very much financially viable. This is about the BharatNet project.
ऑप्टिकल फाइबर कनेक्शंस ऑर्डर दिए गए हैं जबकि कई सारे पर भी पहुंचे अब तक 4 लाख से देश भर में बिल और इन कनेक्शन के ग्राउंड इम्प्लीमेंटेशन की बात करें तो इसके शुरू होने के बाद में कुछ बड़ी दिक्कतों का सामना इसे करना पड़ा है और आगे चलकर इस पर काम करना बहुत ज्यादा जरूरी है इसमें से वन ऑफ द मोस्ट इंपॉर्टेंट दिक्कत जो देखने मिली है वो है लॉन्ग टर्म पैक्स दोस्तों जब भी कोई भी इंटरनेट कनेक्शन हमारे घर पर डाउन होता है तो हम एक को लेकर विद इन कुछ मिनट्स या फिर आवर्स के अंदर हमें अपना इंटरनेट कनेक्शन वापस मिल जाता है एक सेट है कि कोई भी रिपेयर या मिस्टेक जल्द से जल्द ठीक कर दी जाती है लेकिन कई सारे भारत से कनेक्टेड गाँवों में ये दिक्कत देखी गई है कि अगर किसी भी कारणवश इंटरनेट कनेक्शन का डाउन टाइम आता है कुछ भी बिगड़ जाता है तो उसके बाद में उसे ठीक करने के लिए कई दिनों कई हफ्तों और कुछ केसेस का समय लग जाता है जिसके कारण रिलायबल इंटरनेट कनेक्शन आज भी यहाँ पर नहीं है और इंटरनेट डाउन होने के कारण चीजें बंद हो जाती है और इस रिस्क को अवॉइड करने के लिए कई सारे गाँवों ने 100% इंटरनेट पर डिपेंड रहना सही नहीं सकते और इस पर भी बहुत ज्यादा काम होना बाकी है कई सारे गाँव में विभिन्न ग्राम काम करेगी और ना सिर्फ ग्राम पंचायत लेकिन एक्चुअल में जो लोग हैं उनके घरों तक इंटरनेट पहुंचाने का काम करेगी। इस पूरे प्रोजेक्ट की अगर टाइमलाइन की बात करें तो 2022 तक ये टारगेट रखा गया है कि पूरे के पूरे ग्राम पंचायत को इस तरीके के ऑप्टिकल फाइबर नेटवर्क के जरिए जोड़ दिया जाए और धीरे धीरे हमारी ऑलरेडी डिजिटाइजिंग गवर्नमेंट वर्कफोर्स को और ज्यादा बड़े पैमाने पर डिजिटाइज किया जाए। स्पेशली आगे जाकर लैंड डीलिंग्स और गवर्नमेंट स्कीम्स को 100% डिजिटाइज कर दिया जाएगा, जिससे कारण ये काम बिना इंटरनेट के नहीं हो पाएंगे और भारत की इम्पोर्टेंस और ज्यादा बढ़ जाएगी। दोस्तों ये प्लान एम्बिशियस इसलिए है क्योंकि कई सारे देशों में इंटरनेट पहुंचाने का काम पूरी तरीके से प्राइवेट एंटिटीज के हिसाब से किया गया है और सरकारी कंपनीज ने इस पर ज्यादा ध्यान नहीं दिया। इंडिया एक ऐसी कंट्री है जहाँ पर गवर्नमेंट बिना प्रॉफिट से ध्यान रखते हुए कई गाँव में जहाँ पर 100-200 लोगों की भी आबादी है वहां तक इंटरनेट पहुंचा रही है और उम्मीद करते हैं कि हमारे
So you would have got some new idea about Now I come to the topic of today's theme, resilience infrastructure. First background of where I come from, so it will help you to ask me the right kind of question later. Now we are doing a lot of urbanization. When we think development means creating cities and then urbanization. Till now, when we want to create cities, people want to leave the jungle to a place together. In the past, it would have been some other reasons, but today it is becoming a bigger problem. The impact of this urbanization, just that thought initially, before we get into the solution. What we are seeing from year 2010 to 2050, consumption of DMC, that is 1 unit of domestic material consumption, which how much steel, cement and sand we are going area, that is going to get more than double. Right now in 2010 we are 41 billion tons, which is going to be 88 billion. And where this is going to get used, why is not in the Western countries. Maximum users at 100% would be Africa. The most of the development is going to take place there. Second comes our region, the South Asia, where we expect almost 223%. So right now we use about 2.7 billion tons, which is going to be 8.6. Third comes Southeast Asia, led by China. Some other countries in Central and West Asia, you see everyone is going to be in 3 digits. Whereas the Western countries, Europe, America, they are only in 2 digits. Data. What is going to happen? When 3.5 billion people are living in the cities, going to turn up 6.3 billion people by 2050. The city covers only 2% of world land surface on the earth, but it consumes more than 75% of the material on the earth's surface. 2% space getting overloaded with 75%, but going to create a number of problems. 80% of the people will shift into the cities, which is currently 55% people living in cities. Material consumption will go close to 89 billion tons, And what it will lead into the maximum, right now the consumption is very high in the developed countries, the Western countries, which is almost 10 times of the poorest countries. But in future, it is going to be in Asia and Africa. What consequences and challenges it brings to us? Why we are talking about resilience infrastructure? Climate crisis, global pandemic, aging infrastructure, economic uncertainty, budget constraint, disrupted labor force, all these challenges, this urbanization is going to bring for us. And out of this, building itself will account 30% of global energy consumption and 28% of energy related carbon emissions. Consequences would be pollution and carbon emission, the end result with increased material consumption. That's where this thought comes. Till now, the race was about in the past couple of decades, how to urbanize, how to make buildings. We wanted a settled life. But today we have come to this thought where all this is leading into. Particularly COVID has brought those lessons for us. What is the mitigation we are looking for that? Simple, how to reduce carbon emission and resource efficient usage in the city. But immediately in urban infrastructure, to make it more resilient, we need this. Reduce carbon emissions, extreme weather events. This is what now we are planning, what can happen in future. How to reduce waste. Till now, our concept about in the cities was how almost if you see 25 years back, city means what you do with your solid waste, dump them in one corner. We created a lot of landfills. We have reached to the stage where this thought we can't generate any more waste. Whatever waste we are generating, we need to convert them into useful things. That reduced waste has to be zero waste. And then preserve natural resources while still providing critical infrastructure. Then we need greater transparency in all these operations. What it means, what happens initially, even in big cities I've been observing when government dictated you need to have this dry waste and wet waste separately, appoint one agency. You can't throw it to the municipal corporation. You find an agency who lift it. Where they drop it, nobody knows. We just get away that we are not giving it to the municipal. Now the thought process has to come where it is ultimately going and how it is impacting. This is where one of the things going to impact again from a smart city, that digital transformation is there to monitor and help to that extent. There are a lot of tools which can move us from a reactive response to a sustainable future. Then saving the cost, connecting with the trusted data, all ICT enablement of all these things. So like when we think of solid waste management, now we can monitor whether it is picked up, where the truck's location is, and where ultimately it is dumping, where we are ending into, any kind of analysis. So digital transformation is one of the key in making those resilient infrastructure, whether it is monitoring, control, measuring the end result. This is where it is going to help us. Again, we think of what are our recent events. All these in media headlines. Why today this situation? It's not happening only in Joshimat. Like this sinking city reaches new low. Some houses are marked X. This is all unsustainable development happened in those places. And now it is not limited to Joshimat. Almost all the pilgrimage area is coming into this hunt. It could happen to other cities as well. If they some more pictures. So what was the cause of that? Uncontrolled construction work, overcapacity. They have Alaknanda river around there. Lack of drainage system in the city. It's situated in old landslide area. Some people are blaming that Tapovan Vishnugarh project of NTPC is responsible for that. But in summary, it is uncontrolled construction, ignored warning, and it created a unsustainable cities. So now when we are thinking of resilient infrastructure, the whole thought process has come that how we are generating the cities of tomorrow and how they can sustain, how we can take our past learning from there. So the Joshimath example forces us to rethink on all those development models. And you know, half a dozen experts are sitting over there from all elite institutes studying that. Not a great situation, but it's a great warning for us. With this, I again come, what is the latest watershed moment in India's history? And I mentioned about the Amrit Kal. Now we have got the G20 presidency. And it is opening many avenues to think on this line. So when we are giving our message of Vasudhaiv Kutumbakam, not for any political reason I'm saying, but more from a resilient infrastructure and for environment, we believe the world is one family. It's not with political boundaries of countries or religion, but how we find pragmatic solution to well-being of all. Of that, it's a golden moment for this generation that we got into G20, and it has come up with so many sectors where we are working. I will take you few of them. So in G20 presidency, we have got these 16 sectors to work on. Some 4 or 5 are directly related with infrastructure, where we need to look into what we are doing on them. And that will give you a lot of thoughts. So as a student, you need to see not on a very big picture, but even a one leaf of that. Is there the work I am doing is related to that? Is there a business idea over there which can help someone to penetrate in that business problem? Identify those problems and get into. So some of these areas are renewable, health, digital India, this sustainable development goals, startups, which could be direct interest of you. I'm going to just talk about. If you see in renewables, India is already well placed. We are 3rd largest renewable energy in the world, 4th largest wind energy, 5th largest solar installed capacity. And this number are going to change. Like we are following up 3rd largest economy in the world in next few years. By the time this number will also come in 1st and 2nd. Rajasthan is one of the leading states in solar power and wind energy. And we look for that sustainable planet. That Vasudhaiv Kutumbakam is more towards this, how we create a sustainable. So our International Solar Alliance, disaster resilient infrastructure and climate justice central to the climate changes. We are well placed on them. And already COP21 targets we 9 years ahead we have completed. We have improved almost 25% in non-fossil fuel. LED bulb campaign, I always feel proud of that. So out of that 40 million tons annually, I contribute 1 million ton from my project. Then faster adoption of electric vehicles. My view, I don't know how much it has happened, but in next 2 years, all these diesel and petrol vehicle will become things of the past. That way, we take advantage of our large population, large education base. EVs are going to be big change. Almost, I predict after a decade, all these petrol and diesel vehicles will be in museum. At least for all the purpose, commercial purposes. Only they will be in museum. Somebody wants to maintain a diesel engine and they will have, but that adoption is going big thing. The biggest change there can further help it development of batteries. If you heard of now, many people have developed those capacitor-based batteries where leakages are, right now the biggest problem in electric vehicles is battery storage. Even that is with Solar Alliance and those things. Almost the efficient batteries are still not beyond 60% of capacity. But Capacitor-based batteries are almost 100%, 99% efficient, and their lives are predicted 30 to 40 years. Means in one generation, you install them once and then capacitor battery. Its commercial production once takes place, the will change like anything. Namami Ganga is another project. Fortunately, in Rajasthan state, you must be knowing about Dravyavati River project in Jaipur. That is done by Tata Project. Dravyavati Regeneration Program. Digital India, I already talked about broadband BharatNet project. So this optical fiber network is creating a backbone for India for all future development, smart city and smart development. We have this one like Gram Panchayats connections. UPI is another success story. I tell you, almost 2.5 decades back, usage of credit card was not much heard of. It was only used by elites or the rich people, or it was more of a status symbol. Say, digital payment is in, each one of you must be using it. And all must have adopted in last 3 to 5 years, not beyond that. That penetration and those things are taking India in a way high. In fact, this Bhim UPI is a big success story. Now it is going to Singapore, UAE, and Bhutan, Nepal. That ease of money transfer still doesn't exist even in US today. Like there was another video that if some of you travel to US, in India today, you don't bother to share your mobile data with anybody. It has become a free thing, unthinkable. In US, using mobile data still costs a lot. And there the habit of people is, if my kids use it, they use the data, switch off the data. And then when they are in a mall or some shop where free Wi-Fi data is there, people still have a habit of using free Wi-Fi data or broadband data at home. The mobile data is still very costly thing in the. Whereas India has progressed, and that is with a 125 crore people using it. Big achievement. Likewise, there's a benefit transfer schemes. So some of the perennial problem of Indian democracy, Garibi Hatao and all these things happening for many, many years. In recent time, this digital transformation is removing those problems in entirely different way. Earlier, any Garib getting money, right now also how much, no, but things have improved. I would like to share my experience. About 8-10 years back, I was involved in Aadhaar implementation program for Madhya Pradesh state. Now the format has changed a lot and Aadhaar has become a very common thing. 10 years back, it was optional, have your Aadhaar, but then government made it mandatory. All the BPL people to use it, and that time all the states were asked that you create your own Aadhaar hub in the state level so that all the state department can use it. And we had taken a project for Madhya Pradesh state, and initial thought was to create a 360-degree profile of every citizen there. You won't believe the kind of data it generated. What we did, we took the all 8 crore resident of Madhya Pradesh record into Aadhaar and then started matching them with the Election Commission data, their Vruddhashram pension data, BPL data, RTO data. And it gave us very interesting data. For example, the person who is taking BPL benefits is already having 4 vehicles registered in his name in RTO. For example, Election Commission shows certain citizens already dead, but they are already taking the Vruddhashram pension in the that scheme. And that's why a lot of political opposition has happened, and some Supreme Court directive has made it mandatory, no such referencing can done. Just to let you feel the first hand what I know, so this project was hardly for us 12 crore rupees state government is spending creating this hub. But the kind of proliferation happening into the government system in that pension data itself was more than 150 crore per month. And our law and order and political pressures are so much, even after finding this all people are dead, you can't stop those pensions. Otherwise, there will be another hue and cry. Only the legal step you can take, that list is provided to every district collector, that these are the suspected case. You can't say these are dead case. These are the suspected case. Please do the physical verification of all these recipients. But I'm trying to show you what power the technology has and how much savings we can do. Direct benefit transfer I have shown you. So at least the money is going. Even in scholarships and pension schemes, there were a lot of fraudulent entries. With Aadhaar implementation, it is one of the most successful, largest program in the world. Many such duplicate entries and benefits have been protected. So good governance definitely resulting out of it. In fact, during the COVID period, the vaccination program has the backbone of Aadhaar. Had Aadhaar already not in place in previous government, wouldn't have possible. Even in US, when they are doing the vaccine shot, they give a paper slip, and that's it. But in India, no one can claim that it is not done or it is not properly, and still that is going to the next step. I'm waiting for when we do this air travel. I think they already implemented it in Delhi, Varanasi, and Bangalore airport, that you just give your thumb impression or the face, it will automatically detect what is your boarding card and you pass through the security gate. So it wouldn't have possible if all this backbone of IT, data collection, and it requires in India, particularly with democracy, we have the pros and cons, that legal support for all implementing those things. Thought about Digital India. Arogya Setu and CoWIN I already talked about. Now coming to environment. We have given a program in G20 about lifestyle for environment. So now whatever we want to do, we want to connect it with environment. I think this is, if we see it back 100 years back, it is all the culture we have born and brought up with. Why in our country we worship everything, you name the things, any kind of animal or any kind of tree, it is connected. And now if we think back why our ancestors would have done that they wanted to protect them all. And living with the environment, even living with harmony with animals also. And all that thought goes again over there. So we want to do all P3 Pro Planet People movement. This was in Davos, our Prime Minister has announced. Likewise for climatic action. So we have target to reach our net zero emission by 2070. 40% share of renewable India's energy mix. I think biofuel is one of the biggest thing happening in India, which can cut our import bill to a great extent. We plan to have 2,400% growth in solar installed capacity in less than 8 years. All this will take leapfrog to the, and that's where the development is coming. So our commitment, still we have to reach there, but I think we are moving much better in today's age. Like no poverty or zero hunger, or whether we are reducing it. Happens, whatever we claim, there is another set of data to verify. Information technology, media, information, things are more verifiable compared to a couple of decades before. We don't claim we are zero hunger free, but today it is, media can reach it and show it where people are dying with hunger. Yes, in few years back, it was not possible. Now finally to startups. Today we have 107 unicorns. So maybe with IIT Jodhpur, I expect some student take up that challenge and create a unicorn from here. Pick up a business industry idea and take those kind of objectives for you. Today, if we see the gender equal patient, there are a lot of women so freely and the participation of women is much better. we have so many startups in place with this. And my thing, so we have this Panchamrat roadmap by Government of India, where we want to reduce on fossil fuel, energy, renewable energy, reduce carbon emissions. But all these targets, why I am revising, you should find where you can contribute into it. You need to pick up just one of this, how a business idea can come, and finally your idea will not flourish if it doesn't make a profitable business. This, I end myself. If you have any question or at any, thank you for your time.
Thank you, Mr. Inani. It was really a wonderful session covering various smart infrastructure and design. We are already running out of time. I think we can have one quick question. Please introduce yourself before asking.
I'm Shivansh Gehlot from.
I don't have the detailed plans, but mostly it is encouraging the renewable energy resources. Mostly it is aligned with the solar power, wind energy, waste to energy generation, nuclear power also. So those plans are very much reachable on that.
Thank you, sir.
You can ask me question in letters. Thank you very much.
Thank you, Mr. Minani, once again. As a token of gratitude, a small present from our side. Now I invite Professor Anil Tiwari, Professor Electrical Engineering Department, to give the memento to Minani. Thank you, Professor Tiwari. Now I invite Dr. Ranju Mohan, Head Civil and Infrastructure Engineering, to present an overview on resilient and smart infrastructure at the rate of IIT Jodhpur. Dr. Ranju Mohan is the head of the Department Civil and Infrastructure Engineering and also affiliate faculty, School of Artificial Intelligence and Data Science. She does research in traffic flow modeling and dynamic traffic assignment. She completed her PhD in civil engineering from IIT Madras. She also completed her postdoctorate at IISc Bangalore. What to you, Dr. Ranju?
Know that this session is going late, but still, I think all that other invited experts want to hear what is happening at IIT Jodhpur in the domain of smart and resilient infrastructure. So hope you are enjoying all the sessions, including other sessions, parallel sessions happen. I'm here to brief you on the initiatives at IIT Jodhpur in the domain of smart and resilient infrastructure. First, I will take you through our institute vision and what we envision in the domain of smart infrastructure. We will also see academic programs and ongoing research activities in this area, about a thematic center and the company, later about the possible collaboration opportunities or modalities. IIT Jodhpur envisioned to be a future-driven institute for nurturing excellence of thought, creating, preserving, and imparting knowledge, and using transformational technologies and interventions with a multidisciplinary approach for responding to societal challenges and aspirations. We are also envisioned to become an internationally renowned center of excellence in education, research, and innovation with a major focus on sustainability and digitalization of infrastructure. These sentences I have heard from the vision of Civil and Infrastructure Engineering Department. And we made a lot of effort to complete the vision document of the institute. So I thought we should actually showcase this is a vision of the institute. Now, how we are executing it, because I already mentioned internationally renowned center, all these things. So everyone will be telling, okay, we want to become like that. So what are the initiatives we have taken for that? How we are going to execute it? We have faculties working in the domain of this smart infrastructure through isolated or collaborative research manner. We will go through a few details of it in the later slides. We have Department of Civil and Infrastructure Engineering offering an academic program focusing towards integrating advanced technologies with conventional civil engineering domains to design, build, and execute solutions to societal issues using smart and intelligent engineering. We have in our institute an interdisciplinary research program where students and faculties from various disciplines work with a collaborative research approach. Faculties in this domain are also engaged with Section 8 companies in our campus, targeting problem-specific and translational research outputs. It's very, very important, which nowadays the industry want, translational outputs, and we actually will get benefit out of that, like outcomes. That's the difference between output and outcome. So here, industry want the translational research outputs. Here I have shown an outline of current academic initiatives in the domain of the smart infrastructure. Apart from individual faculties who work in this domain, we have two interdisciplinary research platforms. One is in Internet of Things and Applications, where we are working on integrating technologies in various areas, including materials, devices, sensors, circuits, communication, and data analytics for multidisciplinary applications and IoT system development. The second one is robotics and mobility systems, where faculties are working in robotics, including aerial robots, swarms, field, social, and medical robots, and humanoids. And mobility system including e-mobility, autonomous car, sustainable transport, electric vehicles, and hyperloop. So most of these IDRP will be having core faculty as well as affiliated faculty from various departments. In the Department of Civil and Infrastructure Engineering, we are offering programs. For example, we have MTech program, MTech Infrastructure Engineering programs, which are highly interdisciplinary in nature. One is with specialization in energy, and the other one is specialization in environmental engineering. The department also offers BTech in Civil and Infrastructure Engineering with specialization in environment, energy, and smart infrastructure. When speaking specifically about the uniqueness of our BTech program, the department offers, we are trying to integrate advanced technologies, as I mentioned earlier, with conventional areas of civil, including geotechnical, transportation, environmental, structural building services, energy, and safety engineering. The department also has a smart infrastructure design and simulation laboratory, which is under the development stage. Here we provide hands-on experience and response monitoring of instrumentation such as sensors, accelerometers, strain gauges, LVDTs, fiber optics, smart sensors, etc. So this laboratory is still in the development stage. So we wish to have support from industries for this lab during this stage. Under the theme of smart and resilient infrastructure, we are doing research related to transportation, energy and power infrastructure, and structural health monitoring, climate change and impact, and building information modeling. I have sample research problems to share with you. Faculties are doing, who all are the faculty, but I will be mentioning only about few faculties. So who are present here, if I am missing anyone, yeah, please forgive me. Because these slides I have prepared along with the coordination with Dr. Ravi, whatever I came to know about the faculties in the last 3 years. Okay, so if I left anyone, please forgive me. Dr. Ravi Yadav from Electrical Engineering is doing research on resiliency of power infrastructure against climatic extremes. The research focuses on modeling climate change, assessing its impact on power grid, and design and developing resilient solutions. These are some of the result of his research work. I think this is a more technical. Dr. Ravi, during our interaction session later, we can talk more about later. We have Dr. Sharan Athar. His research is to assess the risk and impact of hydroclimatic extremes on a variety of infrastructure, including transport, water, and energy. Dr. Sharan's recent project include real-time drought system, flood risk study for Surat Metro Rail project, and mainstreaming climate resilient road infrastructure. We have Dr. Deepika Bhattu. She worked in the area of indoor air quality in microenvironments and their health impact. Dr. Deepika and her group works on indoor air quality, where they try to understand the sources of indoor air pollution and physical and chemical characteristics of the pollutants. They have done such a study in different microenvironments of our campus and estimated human exposure and particle deposition in the human respiratory system. We have Dr. Pradeep Kumar Damala. He is not here. He is in US now till February end. He focuses on how the underlying soil and its interaction with the foundations ensure seismic stability and safety in case of critical infrastructures of such as offshore wind harvesting, nuclear power plants, double-lane multi-level bridges, multi-story buildings, etc. His research highlights the importance of development of design strategies to study and establish dynamic soil characteristics of soil from seismic active regions. So he wants to end up with region-specific soil models, which will be directly beneficial for government bodies, R&D organizations, public and private infrastructure firms. We have Dr. Ravi Prakash. I hope my lecture or whatever the talk is not getting bored, because I can hear few voices also from the back end. So please listen for some more time. Dr. Ravi Prakash Research Group works on various emerging aspects of building information modeling. They include advanced BIM models, BIM-based rating system, BIM LCA integration, and digitized building permits. So far, they have developed fire safety integrated BIM models, BIM LCA integration toolkits, etc. Dr. Debasis Das, he is from computer science engineering. He has a vehicular ad hoc network lab, VANET lab, that conducts research on spatio-temporal anomaly analytics in city spaces. What do you mean by this anomaly? Where he is mainly concentrating on urban anomalies. Urban anomalies are abnormal events like congestion, crowd gathering, road accident, natural disasters, etc. Specifically, the research focus on city-specific, location-specific anomaly prediction in urban areas and solution identification based on deep learning techniques. Route recommendation based on risk prediction, crime management including pattern understanding, informatics prediction, and suggesting optimal patrolling. These are his some of his research area. And myself, Renju Mohan, works on traffic flow modeling and management area. Current research focuses on developing algorithms to assign dynamic travel demand between origin and destination in a transportation network consisting of multi-class lacking lane discipline traffic. The research is to identify vehicle class-specific shortest path that vary from time to time based on the fluctuating travel demand on the network. The project is funded by DST. Another project is to highlight the synergy between traffic flow modeling and driver behavior modeling. Both need to model together, serving as input to each other. On the same note, research is going on to develop a two-way interactive driving simulator where the subject vehicle react to, 1 minute, subject vehicle will react to the traffic environment and the traffic environment will react to the subject vehicle. So existing simulators we have, other than few in the research laboratory in Purdue and Georgia Tech, we only have one-way interactive simulator where driver can react to the traffic environment created by the machine. That's all. So how traffic environment will be reacting to the driver, that is still it's an ongoing research. It's also, this research is also helpful in the autonomous vehicle design or connected vehicle design modeling. Now, what happened? We are also doing research with translational values under a co-development platform with the industry. I hope my slides were visible, right? Recently only it went off. Okay, thank you. Now, finally, Dr. Amit Kumar Rati, his research is on deep learning-based structural condition assessment technique for infrastructure such as wind turbines and bridges. At present, the research group is developing a DL-based algorithm, deep learning-based algorithm, to determine the damage location and severity, predictive schedule maintenance, retrofitting, repair, and subsequently avoid any future catastrophic situations in today's smart infrastructure. The group is also developing graphical user interface for efficient reliability assessment and robot design techniques for infrastructure problem. Here they have developed different dimension adaptive technologies or techniques using meta-modeling based approaches such as response surface method. These are our mainly technical things. That is why I have written each and everything. If some experts are hearing, I should not miss any words. Okay. So I have highlighted very few research topics here. We can discuss more during the interaction session. I request faculties in this domain who present here to elaborate on the research if there are any specific queries from the audience during the interaction session. Now, I'm ending up with 2 to 3 slides. Our institute has a Center of Intelligent Infrastructure under the School of AI and Data Science. Faculties from different disciplines of engineering and science are affiliated in the center. We focus on advancing knowledge in sustainable and intelligent infrastructure system through transdisciplinary research. What is the difference between transdisciplinary and interdisciplinary? Transdisciplinary, there will be a specific problem. All faculties from different domains will be working on the problem from their expertise knowledge domain. So we already signed an MOU with a TUM Germany. It's not the center. The school has signed an MOU. The center actually was a backbone for that MOU. Now, finally, we have this Jodhpur City Knowledge and Innovation Foundation. That is a foundation on the campus. It is a Section 8 company established in March 2021 to carry out and sustain the activities of Jodhpur City Knowledge and Innovation Cluster, one of the 6 science and technology clusters in India, which is an initiative of the Office of Principal Scientific Advisor. Under Jodhpur cluster, several collaborative applied R&D projects are ongoing under 6 verticals: medical technologies, water environment, handicrafts and handlooms, tar designs, I-governance and IoT Innovation Hub. So I have marked here I-governance and IoT Innovation Hub, which is, I believe, which is more relevant to this smart infrastructure domain. Ongoing research under I-governance and IoT Innovation Hub are highly relevant in this domain. The objective of the I-governance vertical is to roll out an AI-driven initiative for increasing the efficiency of traffic management system of the city of Jodhpur. IoT, basically a combination of AI and IoT, basically deals with the fabrication of different MEMS and nanotechnology-based devices, sensors, that are having applications in different fields such as biomedical, food processing, industry 4, transportation environment, water quality, and many more. Our IIoT lab consists of distinct micro-fabrication equipment, state-of-the-art device fabrication equipment, and also houses precision characterization tools like water level, prop station, thin film, profilometer, etc., etc. So whoever attended the previous session of sensors and IoT, Dr. Ajay Agarwal might have briefed about all these things. But still, all these lab in our IIT Jodhpur is relevant to this smart infrastructure vision our IIT is having. Now, finally coming to the collaborative modalities, we are open to all the CSR projects from the industry, which looks for the quick and this translational output. I believe faculties at IIT Jodhpur are able to do that, and they can actually make a good impression on the industries by showing the talent. Not only faculty, students also. That's why the importance of the startups and everything. I have only shown a few areas of research which will be interested for industry, but if any other areas, yeah, please kindly let us know so that we can discuss again. We have several MTech executive programs also in our campus, mainly for industry professionals. Artificial intelligence, data and computational sciences, intelligent VLSI system, AR and VR, robotics and mobility. Okay, all these are started from 2020-23 period, last 3 years period. Industry personnel can benefit from all these programs and can visit campus, spend time with interacting with faculty and students. We can also think of short-term internship program with faculties. Through our Office of International Relations, Alumni Relations and Corporate Relations, we would also like to have an MOU with industries as an initiation of all these collaborations. So with this thing, I am concluding this, whatever initiative I can brief about IITJ in the light of smart and infrastructure engineering. I hope everyone could get a brief idea of it, right? What I wanted to. Thank you so much. And as I mentioned, if any questions from the industry expert also related to transportation, I will be able to answer. And Dr. Dabas is also there. And other domains experts, yeah, please be there for the further interaction. Now, in the interest of time, I think we can move to, or
Yeah, we can have one quick question.
okay. Yeah. Recently, right, our keynote speaker, he mentioned about smart transport and smart traffic. Anybody got an idea of what is the difference between that? Both are transportation, right? So what is the difference between that? Actually, I was having that question, but in my knowledge, it is transport is related to the planning, traffic is related to the management. Is it like that, sir? What it is? I am asking question now. Sorry, since I am not getting questions from there.
I don't know the, hello?
Yeah.
I don't know the official answer, but my understanding is transport is the physical transport. So whether you are metro or smart bus or whatever comes, that is the transport. Traffic is what is on the ground.
Okay.
So when you have a problem of traffic, means the congestion is on the ground or on the road, or whether it is on the rail or whatever means of, whereas transport is the physical means where the crowd is loaded.
Okay. Essentially, how the demand can be. So
Yeah.
we are planning at the planning stage.
So when you are planning for the transport, how many passengers load is there and where they can go, but the traffic is not related to the passenger itself, but how many vehicles on the road and the congestion is happening. So traffic is related to that.
Yeah, so transport is related to the planning stage, and traffic, it's already demand is there, how we can manage it, right? The
Yeah.
crowd and everything. Okay, thank you, sir.
Thank you.
Thank you, Dr. Ranju. Now it's the time for panel discussion. We have 6 distinguished panelists from industry and IIT Jodhpur. Let's welcome them on stage. Mr. Ashish Deshpande, currently leading infrastructure team, cities, Bureau Happold, India. Worked from concept note
smartest people at sitting in this hall. Of course, I'm a civil engineer, but I forgot everything. So people know me, I have become a social engineer. So I have forgot all geotechnical and other things. But also forgot the definition that how things transformed into disaster. So disaster has become a buzzword. And in the keynote presentation, Mr. Inani has presented about the Yoshimat scenario. You might have seen one of the photographs where this much wide crack is there. Only 2 weeks back, without any other help, the group that you have shown in that, but sending a team and doing the at least drone survey on a limited area, and then getting those data and getting that video of that, the kind of cracks that has created. And if it rains again, rain anytime it can happen. And whatever for the last 1 month, today it has become 1 month. And whatever observations that we have made, whatever committee that has been formed, or whatever meetings are taking place, whatever nightmarish situation is going on among the committees and cabinet and everyone, everything will be just go by smartness that we are showing. Everything will go into vain until and unless we go there and take it and close those gaps or do some kind of survey there itself, that what is going on inside. But when we see that number of explanations are coming up, whether NTPC things are going to have caused anything or not, these are all flowery words. We are engineers. We have to go to the site. Upper side we have seen, but inside what are the interaction taking place? For that also we have got a lot of instruments. Geophysical instruments are there. So we have to check that what is the depth of that crack. White only we have seen here. When next spell of rainfall will be there, then how this water is going to percolate. And when percolation will do, then what will happen to the already remaining buildings? So we have got all sorts of 3D, like LiDAR imagery and everything can be done within no time. But they are able to identify when 1 millimeter crack is there or not in the building, all tilting and everything, which we are able to get it in our computer by taking one survey only. But what is happening inside and what kind of remedial measures to be taken, whether people are to be shifted or not, or building can be rehabilitated or not, that kind of decision as well as courage to go to the field is of urgent necessity. This is one thing that we may become very much smart and putting thousands of sensors and we can increase. We can have facility curve and everything we can have. And we can do twin model or whatever models are there we can do. But addressing the things and from the viewpoint of administration that they are facing the challenge, that whether they are to be shifted or not, there we have to come in between from the engineering, from the professional association. Just another point I would like to see that we have more than 100 plus or 1,000 plus professional association in the country, whether it is civil engineering, whether it is geotechnical engineering, water resources, there are many professional societies are there. Elections are held, these days online elections are held. And so there are committees and conference seminars, everything is being done for increasing our knowledge domain. But one thing is about the infrastructure, which is the main thing over here. We have not yet started health checkup of our infrastructures across the country. For your information, that we do not have even dot information about 5 crore bridges that we are having, about 38,000 bridges that railways are having. We do not have dot level of information on a Google Earth that which is easily available. So I would request that this kind of exercise has been done in some other country, to name that American Society of Civil Engineers. From 98 onward, they have got a professional team checking that all the 50 states, means in USA, that infrastructure, health, grading system, giving A grade, B grade, C grade. That professional agency, this team under AC, they have been grading each of the infrastructure. There are more than 19 infrastructure they have made. Every 3 to 4 years after they make the infrastructure grading. But in our country, we have not yet thought of that. And they are giving that none of their infrastructure, whether it is dam, whether it's a levee, whether it's a canal, whether it's a national park, got more than C minus. We all understand what is a C minus grade. So the infrastructure that we are making, no doubt, it is an artery of our development and civilization that we are going towards. But at the same time, their health mapping, and at least by rapid visual screening, although several cities that they have done, even microzonation has been done of many of the cities, which will never exist. They may exist in paper, but it has to be made more realistic. The kind of remedial measures, whether we can take or not, that is the biggest challenge. So in that case, we need at least 50,000 civil engineers, at least to complete this infrastructure that we are having. And for the next 50 years, we'll not be able to cover. So that is a kind of, civil engineering domain that extending. And we look forward to see and take you, connect you with CPWD kind of organization. Even yesterday, I have been to the Delhi court, High Court, district court. So they need to submit a disaster management plan. Now, disaster management plan, it takes hardly 5 minutes now. Getting the data, put all the phone numbers and mobile numbers, and who is who, their position, but they need to be connected through smart system, at least developing a mobile app. So I'll be very happy to take all the 450 plus establishment of CPWD, where even North Block, South Block, all those things are there under them, their resorts and everything. They are looking forward to us, to NIDM, to help them, making a disaster management plan, at least to begin with in a paper mode. But now paper mode things have to be transmitted to the smart mode by connecting and doing survey, then connecting them. And also already that we have got all this street light and everything we have got network and everything. So there is a huge demand for making a disaster management plan from paper mode to smart mode. So we'll be very happy to join you and take you to that. Thank you very much.
Yeah, go ahead, Dr. Devasas. Yeah.
Okay. Thank you for giving me this opportunity. Okay. So I'm from the academics, so something different from the industry. And currently our team is working in the case of basically designing and development of different type of solution for a smart city as well as a smart transportation. And we have some international and national project in the area of smart city and in the area of smart transportation. And we are basically focusing on the different types of problem like the urban anomaly analytics and as well as some security related solution. And in this case, we are basically using the different types of solution mechanism, basically machine learning model, deep learning model, as well as a security perspective. We are using the security solution, traditional security cryptographic solution, like the cyber security and network security, as well as we are currently using the concept of blockchain based solution, which is decentralized solution or distributed solution for the society. We are trying to solve the different type of infrastructure related problem like beyond the shortest route. We have the solution related to the shortest route based on the different traffic condition, something. But if we add some additional parameter, which is environmental condition, which is the different risk factor, then how we'll optimize the whole thing. Okay, so basically optimization, multi-objective optimization type of problem. Then we also focusing on the how we predict the early stage different type of crime, different type of abnormal activity like accident, this type of work, as well as we are trying to solve the some security related issue, which is during the communication, if there is some informal abnormal activity, then how we detect and predict those type of activity using the blockchain and machine learning based solution. So from the industry, so how we collaborate for this thing, initiate the collaboration with the industry, what type of solution you want, okay, and what type of initiative will start from our side. Okay, so this is the.
So good afternoon, all. I think it is evening now. Good evening, all. So talking about resiliency, as Professor Chandan said, resiliency. First of all, resiliency is not just a design problem. When I talk about it, it has to be the current practice. Now we have to first start from the right from the starting point on the chalkboard. That what are we doing right now? Is it even an initial step towards resilient design? I'll take an example. I'll give you an example of power system or grid control. So grid has been dealing with climate events for a long time now, and still we are using an age-old method where we simply do a rough planning as to which area would be impacted mostly. This is at least the practice which is done by state transmission companies. That's what I'm talking about. Maybe the process might have improved a little bit, but still it is like that. So there will be a rough sketch of the area of impact and a preliminary power cut will be there in some areas, and that is it. So there will be a power cut in the areas where impact could be high. That's it. There is now this is not a smart. This is not resilient thinking. We are not even at starting point till now. Now it has to be now. Another problem, another point that I want to make is, can resiliency and smart infrastructure go hand in hand? Are they inclusive or exclusive? So smartness, as per my understanding, if you improve smartness, if you inject more smart infrastructure into the system, ultimately resiliency can be achieved. So 0 point till now, right now, lot of practices till now are not even at 0 point in terms of resiliency. We have to do a lot in that terms. So that's my 5 minutes.
So I think most of you, like from the industry, you forgot the second point, like how we can connect with, like IITJ connect with the industry. Like you just tell that, yeah, how we can collaborate with you. Yes.
So just taking that point forward, I have one important point that when we are talking about cities, where is the resilience? What is the first thing that happens? I'll give a small example. What IITJ, where can they be specifically contributing? We were doing one flood risk assessment project 10 years back, and the proponent said that we don't want the project because पता है हमको कि कितना flooding होने के बाद में क्या होगा, कैसे होगा. But we are telling that there is a climate change effect that you have to understand. So water resource, not only from the water resource management perspective, but the climate perspective also you have to consider. So what is the damage that is going to do? You will not believe, in last 2 years, we have received 10 times more inquiries to do the flood risk assessment, not just for the sake of doing the environmental impact assessment and submitting the document, but people are scared that what will happen. Cities are sinking. The infrastructure is not prepared for if cyclone or some condition happens. There are 2-3 types of disasters that can happen. Sir will be more authorized to say about it, but I'll saying from the infrastructure perspective, if some water supply is broken, power is not there, how are you going to be resilient about that? Have you considered that the climate change effect in flood risk assessment is actually improving 20 to 30% of the additional discharge that now we are able to project, we are able to model. So where IITJ can do is that the specific projects, it is just one project, but other is that water resilient infrastructure, or you have several I'm seeing the from the electrical or the power systems perspective, there are several opportunities. Green mobility. You have a fantastic team of transportation and mobility expert. So we are doing so many green mobility projects where we can see that in case of disaster, the chaos which happens is in the traffic management and all. So there are several opportunity areas that from city's perspective we can do, and it is not one solution. We have to have an integrated solution. It's not about civil engineering. It's not about digital engineering. It's about IT. So there would be several interfaces that needs to be integrated. We have to provide the integrated solution where you can play a biggest role. So
as I told you to you and all of others that we do research as well. So that could be the primary connect or connections we can make. In that research, say for instance, very recently we engaged some people from Khalifa University, Masdar Institute, MIT. So MIT is one of the pioneers. Professor Herbert Einstein, who is a nephew of Albert Einstein. He is also a distinguished professor there. So there is a research team, research collaboration with the NYU and some other great universities also. We are developing or in the last stage of development of CAT risk. CAT risk means catastrophic risk. Catastrophic could be earthquake, could be flood, drought, sandstorm, those kind of things. If you go to the reinsurance companies like Swiss Re, Munich Re, blah, blah, many things, they always insure or reinsure based on the asset volatility or asset price. Sometimes you pay premium, and then if at the time of disaster, you ask for a contingent claim so that if there is a disaster hit, you get the money. That's the way they calculate everything. And if as an asset manager or if a asset owner, like you are owner of Burj Khalifa, say for instance, you have to pay huge premium to understand that catastrophic risk. If it happens, 100 years there were no record of earthquake or something, still you need to take that premium. And then based on that high premium, this calculation is done through that system, and this is very expensive to install those products. We are trying to do, it's also funded by the government institutions and RSRL and some other bodies. We are trying to do automated and open source. It's free. In that, it is not a collaboration. I'm talking about children or the students who would be, or professors would be invited or involved, is free of charge, nothing. There would be stipend, there would be collaboration, everything. And also at the end of the project, your ambition as an academic always to publish something. That we need to figure it out. So moment we involved some from IIT Bombay, I'm not taking the name publicly because it's a recording. So that's, so I involved them. So they did their publication. At the same time, we developed something that is applied for the government purpose, and that is free. And that's why some of the big players, reinsurance players, they are not very happy, but they cannot stop the technology. They cannot stop the innovation. That's the way could be the inception of our collaboration. Then there could be anything, like I got some interest from the students when they came to me that how can they be part of internship? You know, obviously I'm open. Question you have to design, or question I have to design. If I have to design question, that question would be mathematical. I will only understand formula very well, better than many people. But if you have a question, I need to translate that. If you have a social question, socio-economic question, or infrastructure question, just bring that. We will translate some mathematics. We will train also you guys. So there could be humongous opportunity to collaborate. Thank you very much.
What I understand, connect word. Connect means connection of a IIT-J with industry or any civil engineering. I'm basically, I want to say regarding civil engineering only. So connect of the IIT-J with the civil engineering project, or connection of the student
with civil engineering project during his graduation course or after the job, after for the job. So I just want to tell one thing, because it's a serious concern. It's in my mind since 1987 when I joined engineering college. So I had the opportunity to go to the field for 2 months or 1.5 months as a training. It is now called internship. That training, during the training, I got the opportunity to see a building which was being constructed there in the Jodhpur itself. That duration was only means plastering work. That work was going on at that time. So a civil engineer is not meant for the plaster of only. So any civil engineering project generally takes 2 to 3 years time. Recently, I was involved in the construction of a dam. That dam was still it is under construction, and it's very approachable to this place, IIT Jodhpur. So the students should be engaged with that project for the longer duration. Say if he starts in first year or after first year in the second year, he should be connected with that project, and he should see and observe the things right from the excavation of the dam, excavation for the dam, and then geotechnical investigation, then actual construction of the actual concreting, and then lastly at the time of instrumentation. So connection of the student with civil engineering project like construction of dam should be for the longer duration. It's not that he's going, the student is going daily there, on the daily basis there. It can be intermittent, say once in a month or once in a 2 month. He should visit there and see actual what the construction, how the construction is going there. So it's my view regarding Connect.
Yeah, another area of opportunity for students is that once you come out or you pass out from the institute, you say that what is the organization that I'm looking for, and what is the area of specialization that I am looking for, and what are the best companies that are offering. So are you employable? Are you having those skill sets? Or even if you have a fantastic degree, what is the industry's need? So in the design engineering, there is you are offering infrastructure as core, infrastructure engineering or design. So there, what is the industry's need? Like I mentioned, climate change. There are several other areas where engineering design can be, specific to those requirements, and you can develop those skills. So the modeling part is there, designing part is there, and you can also have the feel with having in the internship program or training programs which we have, that you can get what industry needs and what the requirement from the skill set improvement is there. So those specific things also can be shared and learned.
I think in my first interaction, I told about 3 things. So I'm again making it. One thing is like CPWD kind of organization, thousands of, there are so many establishments are there. So they wanted to have disaster management plan for all the listed infrastructure, about 452 infrastructure that they have, including North Block, South Block, and everything. So they wanted to have a comprehensive disaster management plan, which they have made. But as I said, but now my version is that it is to be taken into a software mode, and so that it will be connected. There are certain formats I have made already. So I would say that we can take it up. In fact, 10 years back, we have written in PHP, but now it is to be made in Java or something, and it will not take much time. So one collaboration will be taking this infrastructure mapping using some of the formats which we can customize based on the type of infrastructure, type of building, type of locality, not only building, concrete and other things, but what are the water supply, what are the fire systems are there, everything together, because infrastructure includes everything. So one would be that to join with them. They have got whatever, money is not a thing, funding is not a problem. Thing is, it is to be done. They wanted only in a paper mode kind of things, which I say that no, it is to be done. We can guide you, that means through only guide only, but it is difficult for us in an IDM to take such kind of project. So it would be good that to have a project with you, that because you are a center of excellence. So funding, giving funding to you is not a problem, but transmitting the things, whatever is there about the infrastructure, at least in a 3D LiDAR mapping, inside, outside, as-built drawing, and then locating all those facilities and emergency vehicle and everything. We have got a lot of such literature. This is one area. Another area, we have made several such capacity building, like snakes and ladder game, like earthquake. What are the do's and don'ts? So when we see that earthquake only, it is do's and don'ts is just for common people. But when it is made into a gamification of the same thing, so we have done certain formats on that, gamification that, with the snakes and ladder. So for that, we are looking for someone or some group of things that just make some program, make it as a game, and make it as a level 0, level 1, level 2. It is an entertainment through learning. So that could open up many of the opportunity for making into a commercial venture. Third thing is that you see that your campus map is having a lot of greenery. But some of the greenery, whichever is there in the master plan, it is all green. But in many places, they are not green. So I have got a special kind of grass. You might have known whatever grass. In this sunlight, it will remain so green, like many of the green trees are there. But exception is, it can go even 3 meter, 4 meter below the ground, and it is perennial, and it will make the entire here that it will recharge the groundwater. Like you do not know what is the groundwater level, maybe more than 200 meter as I was interacting, but it will recharge the groundwater naturally. So it is a nature-based solution to make the things green at the same time that it will recharge the groundwater. So that can be tried because it is naturally available Indian variety. Fourth thing is that cleaning of water, lake water, or you have a lot of lakes here. Those can be cleaned with guarantee that within 15 days by nature-based solution. And it doesn't cost much. And there are several wonderful projects have been done with economics technology. More than 100 plants extract they have mixed. So you may say that it is a homeopathic portion or solution. But only thing that we have to do observation. All those data, DO or whatever pH, just only observation before, after. See that what are the chemical changes are happening. So that kind of project can be taken up immediately. And there are so many lakes are there, nationwide, lot of programs are going on. And even in Delhi also, number of programs are going on. But this kind of nature solution, which costs hardly 1% or 0.5% of the total expenditure for beautification that they are making, that difference we have to come down. Because main thing is cleaning of the water, whether it is river water, whether it is sewage water, whether it is lake water, in situ, it can be cleaned, and already more than 20 plus project has been taken up. With the recognition by IIT Kanpur or even NIRI and even Namami Gange, Water Resource Department. So let us promote that as a social spirit through CSR and see that how changes are happening. Let us not ask the question that what is that material they are making. Of course, if you put it into machine, you will come to know that what is the portion. We know that all those chemical contents and everything. It is not the chemical contents. It is taken very complex material taken from 100 plus, say, plants that available in our country. So we can take it up. These 1, 2, 3, 4 to name just to start. Thank you very much.
Okay, thank you, Professor Chandan. So since we have very less time, so you just summarize one for last 1 minute. Okay, so one sentence from each and everyone.
So another aspect and wrap up comment of this is ESG, environment, society and governance. So if you minutely study through, you will see that one company, big company, maybe one of the biggest companies, is rated by 3 rating companies differently. That means the probability of default or distance to default, those models has some problems. It's not a data science problem, it's a model problem. That model needs to, so if you have any question, so last year I had an article that got viral that article with Sergio Scandizo. He is a regulatory expert from European Investment Bank. Me and Sergio, we are doing these kind of things. Later we can discuss on that because of the scarcity of time. But the thing is that main principle is if you have any question about ESG, related to infrastructure solution, mobility solution, and also overall catastrophic and climate resilience, risk and resilience, please reach it to me. Thank you very much.
Yeah.
So yeah, from my summing up perspective, I just have one point to say that this is a very complex subject: building infrastructure which is resilient. So IIT-J with its diverse team can actually make an impact in one specific area. If you can make it an endeavor, if you can make it a mission to develop these best practices, because resilient infrastructure is not only about working in silos, it is working with like-minded people, like-minded cities, like-minded communities. So IIT-J can actually take the lead in connecting or networking various cities, to begin with in Rajasthan. In India, there are several initiatives like C40 city, 100 resilient cities, where somebody has taken the initiative and they have integrated all the aspects of infrastructure, right from utilities, roads, IoT, or any other thing. So this sensitization and bringing these people together and then developing a community of practice where we can share all the best practices, learnings, place-based solution. You cannot have a fit-for-all solution coming out, but you can still have a solution which is specific to that particular location, but best practices can be shared. So that's a big opportunity area for you, I think. And looking at the faculty's interaction today and the students' interest and the posters you have put in, I have no doubt that if you take it as a mission, you will definitely be the center of excellence for developing resilient infrastructure in India.
Thank you, Mr. Yeah.
I'm talking in respect of Rajasthan only. Rajasthan is the largest state of the country. Its geographical area is 10.45% of the country's area, whereas its surface water, availability of the surface water is only 1.16%. Means 1.16% of the water is being served to 10.45% area. So the scope of smartness is more required in the water sector, water resources area. So I think there's a lot of scope there. So you should be
Yeah, we
some
will discuss.
innovative ideas.
We are also working on this. So here in IIT Jodhpur, we are also doing this smart gridded water network.
That's very good.
So tomorrow, one faculty in the faculty interaction, we will discuss those.
Okay. Thank you very much.
My last thing is, let us have an IDM and IIT Jodhpur program totally funded by an IDM as per our terms and conditions in the month of March. And whatever I have spoken, especially we'll bring whatever grass kind of things here. Class will be held outside the classroom. It will be in the field. 3 days to 5 days, depending on your classes and other schedule. It will be a practical program where all kinds of measurements will be done. Only inauguration will be held in the classroom. Rest of the things will be done in the field. And it will be sponsored by an IDM.
Thank you so much, Professor. Yeah, so Now, we would like to once again thank all the panelists for joining the panel discussion. Now it's time to close the session. So as a token of acknowledgement, a small present from our side. Now I would like to invite Professor Vadera, Deputy Director, IIT Jodhpur, to present the memento to all the panelists. Welcome, Dr. Chitro Majumdar, please come on the stage. Yeah. Professor Chandan Ghosh, please come on stage. Mr. Manish Pariharji, please come on. Mr. Ashish Deshpande, please. Okay, thank you, sir. So once again, I would like to thank all the panelists and on the behalf of the organizers and the partners of the event, there are few take-home messages which we recognize from this session that we need to focus on the long-term training program. We need to learn some skill-based software that we can use in the industry and many more. Okay, and at the end, I would also like to thank all the volunteers. Mayank Tiwari, Jay Goyal, Abhinav Tawar, Mohit Bansal, Manoj Khichar, Rifa Khan, Vishal Tak, and Ashish Kumar, who helped us in each and every aspect of the event. Thank you, everyone. Thank you. Thank you very much.
There is one small announcement for everyone here. I request the delegates to be present here for the cultural events, and all the students can move to their respective hostels.